So, hallo miteinander. Ich hoffe, die Technik spielt mit uns. Willkommen beim diesjährigen AWS Community Day Deutschland, Österreich, Schweiz. Und ich freue mich, dass wir uns heute treffen können, auch wenn es leider wieder nur virtuell ist. Community ist ein wichtiges Thema. Das hat es leider in den letzten 1,5 Jahren deutlich leiden müssen, da wir uns nur selten vor Ort treffen konnten, in einer sehr, sehr beschränkten Möglichkeit. Auch dieses Jahr waren wir uns nicht sicher, was wir tun dürfen und tun können und mussten uns deshalb leider wieder für ein virtuelles Event entscheiden. Aber wir freuen uns, dass wir es zumindest virtuell uns zusammengefunden haben und heute ganz viele tolle Vorträge hören können. Für unser Event nutzen wir heute den Hashtag AWS Community Day und gerne verlinkt uns auch mit unserem Twitter-Handle awscommunity.de, dass wir jetzt erweitert haben, dass es nicht Deutschland, sondern Deutsch bedeutet und somit auch Österreich und Schweiz mit in unserer Community dabei sind und wir einfach eine noch größere AWS-Familie aufmachen. Ich hatte es gerade schon erwähnt, wir hatten das eigentlich etwas anders geplant im Laufe des Jahres. Das Ziel waren Satelliten-Events, zu sagen, okay, uns war relativ schnell klar, dass wir uns nicht alle an einem Ort mit 1000 Leuten treffen dürfen und können und wollen. Aber der Plan war, uns an 4 Standorten in Berlin, München, Wien und Zürich zu treffen und uns gegenseitig zu streamen. Auch das hat leider so nicht gut ausgesehen und sieht auch den Zahlen nach heute nicht so gut aus, als dass wir das hätten verantworten oder durchführen können. Deshalb nun dieses fast komplett virtuelle Event. Wir freuen uns, dass die Schweiz tatsächlich ein Vor-Ort-Event durchführen kann und heute physisch bei uns teilnimmt und auch eigene Vorträge vor Ort in Zürich hat. Die Organisatoren hinter dieser Veranstaltung, mehrere tauchen gerade auch schon auf dem Stream auf, repräsentativ für Österreich und die Schweiz, Linda und Rinon. Die weiteren Organisatoren,
Hallo
Sven,
zusammen.
Markus, Philipp, Andreas, Stefan, Aaron, Bernie und nochmal Stefan, die hier zusammen dieses Event für euch koordinieren. Und wie gesagt, ich hatte die 2 schon angekündigt, vielleicht wollt ihr kurz 2 Worte zu euch sagen. Linda?
Gerne. Ja, herzlich willkommen auch von mir. Servus aus Wien. Also ich sitze da in Österreich und vertrete damit die User Group in Österreich aus Wien aus. Ja, ich freue mich schon sehr auf den heutigen Tag und freue mich sehr, dass ich den ersten Track, also den deutschen Track moderieren darf, gemeinsam mit Andreas, den ihr dann gleich, wenn wir übergeben, auch seht. Danke sehr.
Und Rinon?
Hallo zusammen, willkommen hier aus der Schweiz. Hallo aus Zürich. Wir haben das Glück, dass wir ein hybriden Event machen dürfen. Das heißt, die Leute treffen ein. Ich hoffe, ihr hört es nicht groß im Hintergrund. Und ich freue mich, Teil dieses großen Events zu sein und mithelfen zu können.
Ja, auch wir freuen uns, dass es einfach dieses Jahr funktioniert hat, so ein ortsübergreifendes Event durchzuführen. Auch wenn es, wie gesagt, nur hybrid ist, aber trotzdem freuen wir uns. Auch so ein Event braucht natürlich Sponsoren. Deswegen freuen wir uns auch dieses Jahr, Sponsoren gefunden zu haben mit unserem Hauptsponsor Storm Reply, aber auch unseren weiteren Sponsoren Global DataNet, T-Systems, AllCloud, Evola, Superlumina, Entity Data und IP Labs, die uns tatkräftig und vor allem finanziell unterstützt haben, hier im ganzen Vorfeld Marketing und auch die Preise für uns Swag und Dinge einfach für Speaker, für unsere Game Day und unser versuchtes Deep Racer Event zu organisieren. Von dem her vielen, vielen herzlichen Dank an unsere Sponsoren. Wir werden sie auch noch das eine oder andere Mal unten einblenden. Auf Twitter sind sie auch überall genannt. Und nochmal herzlichen Dank. Ein weiterer Dank geht an die Vorort-Sponsoren Legendary IT, Webgate und Fastlane, die in Zürich unterstützen, das Vorort-Event durchzuführen. Vorort-Events haben natürlich nochmal einen ganz anderen Kostenpunkt, weil ihr alle zu Hause bezahlt euer Essen selber. Vor Ort gibt es das Essen. Das heißt, auch dafür braucht man Sponsoren, Locations und solche Sachen. Auch hier nochmal herzlichen Dank. Und Linda hat es gerade schon erwähnt, wir haben heute 2 Tracks. Tendenziell gibt es 2 YouTube-Streams, auf denen ihr gerade beide das Gleiche seht, wenn die Technik uns nicht im Stich gelassen hat. Das wird sich in wenigen Minuten ändern. Und ihr werdet auf Track 1 5 tolle Vorträge auf Deutsch hören und auf Track 2 5 tolle Vorträge auf Englisch. Die Agenda dazu, ich weiß, es ist ein bisschen klein, es ist auch eher symbolhaft, findet sich auf unserer Webseite AWS Community Day DACH, auf der ihr nochmal genauer sehen könnt, wann welche Vorträge online gehen werden, beziehungsweise live vorgestellt werden. Wir werden von unseren 10 Vorträgen 7 Live-Vorträge haben und 3, die bereits aufgezeichnet sind, aber alle mit Live-Q&A durch die Sprecher. An dieser Stelle auch noch ein weiterer herzlicher Dank an unseren weiteren Hauptsponsor AWS. Wir werden hier sehr gut unterstützt, sehr nett unterstützt, sehr hilfreich unterstützt durch AWS und zwar auch in Person unserer Developer Evangelists Dennis und Chris, die ich hier mal mit auf die Bühne einlade. Willkommen.
Grüß Gott aus München.
Grüß Gott, jetzt versaue ich es mir mit allen. Moin, grüß euch, Servus und Grüezi.
Oh, sehr gut.
Schön, dass wir dabei sein dürfen. Herzlichen Dank. Ich habe gar nicht so viel zu erzählen. Chris, wie sieht es bei dir aus?
Wir haben 2 Tracks und wir haben 2 Developer Advocates and I am the English speaker. So I'm very excited for track 2 today. Very excited for track 2.
Perfekt. Aber ich habe mir zur Vorbereitung nochmal die Keynote vom letzten Jahr angeschaut und da hast du schon auf Deutsch begrüßt, also von dem her keine Ausreden. Wunderbar, es freut mich, dass ihr da seid, dass ihr uns unterstützt, auch gestern sehr stark unterstützt habt, beziehungsweise es komplett durchgeführt habt, nämlich unser Community Game Day Event. Dennis hauptsächlich hier als Operator. Vielen, vielen herzlichen Dank für die Durchführung.
Naja, die Durchführung waren tatsächlich die Leute im Hintergrund. Wir saßen nur vor der Kamera. Und im Hintergrund hat sich ein ganzes Support-Team von AWS darum gekümmert, dass alles glatt läuft und alles funktioniert. Also auch nochmal vielen Dank an alle, die hinter den Kulissen teilgenommen haben. Vielen Dank auch an alle Spielerinnen und Spieler, das Gewinnerteam, das wir gestern Abend dann auch noch vorstellen und kurz auf der Kamera begrüßen durften. Jeder, der nicht dabei war, kann sich den Stream auch noch hier auf dem Kanal anschauen, wobei das wahrscheinlich nicht so spannend ist, weil wir die meiste Zeit nur das Scoreboard gezeigt haben, um die Spieler nicht bei der Konzentration zu stören. Auf jeden Fall vielen Dank, dass ihr uns mit reingenommen habt, dass ihr uns auch die Gelegenheit gegeben habt, dass wir für die Communities so ein Game Day veranstalten können. Für mich war es das erste Mal, einen virtuellen Game Day auf einem Stream durchzuführen und ich hoffe, es war nicht das letzte Mal.
Oh,
ich gehe davon aus. Es sind auch neue Game Days in Arbeit. Den Link dazu hatte ich auch im Game Day Video am Schluss noch gepostet. Amazon sucht gerade Freiwillige für die Beta-Testphase für 4 neue, so wie ich das gesehen habe, wenn ich mich nicht getäuscht habe, 4 neue Game Day-Themen. Unter anderem einen Infinidash. Sie haben den Namen endlich einer sinnvollen Verwendung zugeführt. Okay, das als Insider. Gut. Ansonsten, Dennis, du hast noch ein anderes tolles AWS-Community-Projekt. Vielleicht magst du da noch 2, 3 Worte dazu sagen.
Ja, vielen Dank, dass ich das pluggen darf, sozusagen. Wir haben seit Anfang des Jahres, weil wir im Moment einfach nicht so viel Gelegenheit haben, rumzureisen und wirklich Leute zu treffen und Vorträge zu machen und Workshops zu machen, hatte ich jetzt endlich Zeit, Anfang des Jahres den AWS-Podcast auf Deutsch ins Leben zu rufen. Also jeder und jede, die sich gerne Interviews hauptsächlich mittlerweile, anfangs hatte ich ein paar eigene Sendungen gemacht, aber mittlerweile habe ich ganz viele Interviews mit Kunden, mit Leuten aus der Community, auch mit Leuten von AWS, auf Deutsch, deutsche Sprache, könnt ihr finden, eigentlich bei jeder gängigen Plattform, bei Apple Podcasts, Google Podcasts. Gebt einfach in Google ein AWS Podcast, das, was da steht, AWS, der Podcast auf Deutsch. Dann werdet ihr auch den Podcast finden.
Perfekt. Vielen Dank. Dann würde ich sagen, möchte ich auch dem weiteren Event nicht im Wege stehen. Werde euch 2 vom Stream wieder runternehmen und dafür unsere Moderatoren kurz
viel Spaß
dazu holen. Dankeschön.
Viel Glück.
Genau. Willkommen. Ja, das ist, wenn man hier spricht und klickt gleichzeitig, ist das irgendwie ganz schön viel Multitasking und das kann ich einfach nicht. Genau, deshalb, willkommen, wir sind 4 Moderatoren. Linda und Andreas werden hier euch durch den Track 1 begleiten. Also für die gerade auf dem Track 1 Video sind, ihr werdet sie weiterhin sehen. Aaron und ich werden technisch auf den Track 2 wechseln. Ihr seht uns schon auf Track 2, die Magie macht es möglich. Und von dem her werdet ihr uns weitersehen. Und ich hoffe, wir treffen uns dann sozusagen, wenn die Technik mit uns ist, zum Coaching wieder auf einem Kanal.
Ja.
Wunderbar. Dann übergebe ich das Feld hier an Linda und Andreas. Und auf Track 2 übernehme ich mit Aaron zusammen. Dann
Danke.
Viel Spaß.
Danke, Thorsten.
Ja, danke. Tschüss.
So, ja, es geht gleich los. Ich sehe, wir haben...
Ja, we're live.
So, dann hoffe ich, ja, es sieht gut aus. Mein Kontrollmonitor sagt, alles ist gut. Let's switch to English.
Yes.
My monitor says, I'm live on track 2. Everything was working fine.
Yeah.
Magic on this stream. So, yeah. Thanks, Aaron, for being here, for co-moderating this event with me.
Yeah. Thanks for having me. I'm really looking forward to, I think we've got an awesome lineup of tracks today, both track 1 and track 2. There's some really great talks. So I'm looking forward to brushing up on my German on track 1 on the recordings. So.
Yeah, sorry for this. We were discussing what we do, but as it was the German Community Day, we were thinking like, let's do the welcome in German.
Yeah.
And I hope YouTube subtitles are activated and will be there later on. I have no idea how this magic works.
Yeah. Yeah.
So, yeah, as I can see, we have Vadym already waiting in the staging area. So I will bring him up to the stream.
Yep.
And yeah, welcome, Vadym.
Yeah, thank you. May I share my screen?
Yeah, sure. Share your screen, and I will just put it to the stream. And we are very, curious what you will talk about. And it's about writing less code with serverless on AWS. A very, very interesting topic.
Yeah.
And I'm really looking forward to learning something new.
Yeah.
And here is your screen. So I think the stage is completely yours.
So hello, I would just share my screen. Now I have my laser pointer, so I hope you can see, and slide switching works. So thank you very much for inviting me to speak in this event. I will be talking about writing less code with serverless, and several words about me. My name is Vadym. I'm Ukrainian native, but since 20 years in Germany. So I have 2 passions, Java and serverless. This talk is also about serverless. So you can drop me a message via private email, or I'm quite active on Twitter, but also just to be found on LinkedIn and Xing and so on. So I'm working for the company called IP Labs in Bonn. We are one of the sponsors here, and we offer the software for designing and purchasing of the photo products like calendars, photo books of the year, something like these, prints, posters, and so on. And we are quite proud. We are all in with AWS. We have migrated our second data center this month, so just a lot of experience in the past years, and we are also on the serverless journey, so a lot to share. And with this, this is our agenda. So we'll be talking about challenges of the software development in general, then briefly talking about serverless and its value proposition, and especially diving deeper into this concept of code is liability, own less, build more, lower technical debt. And the main part will be examples of the serverless services and architectures for writing less code. And then we will wrap up how to be successful with serverless. So let's start about talking about the challenges of the software development in general. So just we will abstract away from serverless, from the cloud. So yeah, So general software development challenges. So I really recommend this book, Team Topologies, written by Matthew Skelton and Manuel Pais, and they introduce concept of the cognitive load. And in terms of software development, this is the total amount of mental effort being used for in the working memory. So what do we need to write software just in our context? There are three types of it: intrinsic, extraneous, and germane. And the intrinsic one is probably the simplest one: how to write simple Java class, use framework, simple test framework, and so on. So our day-to-day business. The extraneous, and then the things become a bit complicated. Here is about how to automate tests, so much complex stuff, integration end-to-end, depending what we are doing, web, desktop, and mobile, how to build, package, and run your application. It's also about how to configure monitoring, alerting, auto-scaling, logging, tracing, all this observability stuff, and also how to operate and maintain infrastructure. So we just abstract away from the cloud, how to build fault tolerance and resiliency into your application, and of course, how to make hardware networking applications secure. And just you see a lot of aspects, and sometimes we are in the world of the microservices, of the distributed systems, and these are base building blocks that you need to embrace in order to deliver and run and your software. And sometimes people struggling doing this stuff and just they don't come to write the code. And this is one of the aspects we'll be talking about. And germane one is something related to what is your core. So this is domain knowledge. In case of IP Labs, that this is how to write a good editor so that you can design your photo products. And for example, payment, e-commerce are not our core systems and so on. This is also about your own personal and business processes and workflows. So what should we do about this? So intrinsic, we should become fluent in it. There are no chances that we can kind of outsource this. But with extraneous, our goal should be to minimize the amount of what we implement, operate, support by ourselves. Here comes cloud into play, but also, of course, serverless, and we will be talking about. And germane, this is minimize of amount of what we have to implement by ourselves. Is just focusing on our core business. Just e-commerce that are pretty much very powerful solutions. So don't reinvent the wheel if it's not your core. So generally, how to become productive. So what our managers wants from us, that we are productive, and what does it mean that we are productive? So we are regularly ship products, which should be successfully used by our customers, but just we should regularly ship things. And of course, then now let's talk what is holding us back from being productive. And I will refer, and you will receive the slides of the talk. There are a lot of links below to one of the reports correlated to the poor IT software quality, but there are just the main stuff you will see that it relates simply from what is holding us back from being productive. And one of the biggest things is technical debt. And if you will look into the Wikipedia, you will see some kind of definition that this reflects some suboptimal solution that we choose today, and then we have to pay, just for this technical debt, and then correct the solution. So for me, it's not the wrong definition, because even a perfect solution today can become and will become technical debt over the time. And just we know that the versions of programming languages comes out of the support, and the migration has the cost of not backward compatible changes. So people still using Java 8 know that there is a module system and so on. JavaScript frameworks, that's the story which is always there, like also Angular and so on. So sometimes you just as everything is not backward compatible anymore, you need to rewrite the code. Also, security consideration may force you to upgrade one of your dependencies, libraries, web application server, and this may come also with the support of programming languages of this application server, a lot of stuff. So the people which, we know perfectly that TLS 1.0, 1.1 just shouldn't be used. And of course, if you are just below Java 7, I think then there is no support for 1.2, and the same story will go and then 1.3 will become the standard and so on. So you need to upgrade the stuff, even then the decision was perfect. And of course, we are dealing with a lot of open source software, and just things become discontinued, won't be supported anymore. You cannot upgrade, and there is some kind of security issue or performance issue. You need to rewrite or use another project. So we are always in this loop, like upgrading and so on, just paying this technical debt. And this holding us back. That's one of the hugest points. So think of what can happen. So technical debt, and for me, is think what can happen to your software over the entire life cycle of our product. And the entire life cycle can be forever. Yeah, at least a very long time. And technical debt is related to amount of code written, of course. And it's also about related to the amount of dependencies used. So open source project, programming languages, databases, web servers, application servers, and so on. Everything that we own, that we write, that we run on our own, that we need to pay attention for this. So another point which is holding us back from being productive is just using legacy systems. Legacy systems are, for me, systems that cannot evolve. So you're using some kind of old programming language like COBOL or the very old version of popular programming language, and you cannot update because it just needs a lot of effort and so on. And then you are constantly prioritizing feature delivery over modernizing the system, and sometimes you can get stuck with this and can't attract people with the recent knowledge. And there is this beautiful book, Building Evolutionary Architectures, from Neil Ford, Rebecca Parsons, of the people known from the ThoughtWorks, and they just writing about how to write evolutionary architecture, so something completely opposed to the legacy systems. And they differentiate between so the evolutionary architectures may support these three characteristics: incremental change, appropriate architecture and coupling, and the fitness functions. And probably the first two are quite understandable. So we need to release incrementally, and for this we need kind of coupling just to move quickly. And the fitness functions, everybody has to deal with this. These are source code metrics like measuring cyclomatic complexity, unit test, percentage of coverage or success tests, performance tests such as API latency or throughput, and the security, just like we are checking that all S3 buckets are not public, that we rotate our keys, and so on. And also all the CI/CD stuff that Arc Unit, but also the AWS tools like code commit until code deploy, all this chain also is part of the fitness functions. And the goal of these fitness functions is just to help us to release safely, to support this incremental change, and just validate that we didn't break things, just doing the small changing and releasing them often. So these are all these examples. So now we will be talking for the first time about serverless and just see what it enables us. So usually we will be talking about total cost of ownership. I talk extensively about this in my other talks. Here you see all the stuff that serverless gives us: no infrastructure operation and maintenance, auto scaling and fault tolerance built in. So generally, it's not our core competency to do this. This is something that cloud provider is much better. And this stuff, own less, build more, lower technical debt, that we will now dive deeper. And of course, all this stuff with serverless enables us to focus on business value and innovation and just releasing faster to the market. But let's dive deeper into these two aspects. And own less, build more is, for me, just by heavily relying on the managed serverless services, you can do more with the same amount of people, but just by outsourcing and relying on the stuff that gives you like Lego building blocks. And you can more easily evolve the architecture because you just need to write less code. And lower technical debt is related to this. And I really like this quote from Paul Johnson, who is very much known in the serverless space. And he's telling that whatever code you write today is always tomorrow's technical debt. And that's really true if I think about this, how quickly things evolve. And less code also means lower technical debt. And also less code means less code maintenance, which leads to the I would say, evolutionary architectures, because just you don't get stuck too much in this legacy mode. And think by this that time and effort required for maintaining the solution over its whole life cycle is far much more than developing it. So we are sometimes very quickly at developing something, but generally developing something only means that's only 25% of the effort. 75% will be paid when you're maintaining something. And just think carefully before you start implementing something. Do you need to implement this on your own? So we talked about writing less code. Now this is the question how we can do this with serverless. And this is the main part of my talk. And of course, one of the aspects is simply to write less Lambda functions. And we will see a lot of examples which go in this direction. But generally, what does it mean to write less Lambda functions? It means less code to write, less code to test, run, and maintain. This also brings saving on CI/CD pipelines, with all these stages, but also rollback strategies in case we just need to revert to the older version of the code. It also means less infrastructure as a code, because you save on these lambdas, and each lambda needs fine granular IAM policies, and infrastructure as a code should also be tested. So you save on this. You have less cold start worries, one of the aspects of the lambdas. You also have less point of failures and retries, because Lambda may fail. They will be retried in case they are called asynchronously, even automatically. You have also less security constraints because just of the wrong IAM policies or some kind of poisoned event. And you also have less worries about Lambda limits of quotes. So you know that you may have only 3,000 concurrent Lambda execution per account. This is the soft limit. You may increase this, but then it can only increase, I think, 500 execution per minute to some other limit. So this all these limits, which are regional and per account, you have less worries. And also you decrease spending on Lambda, also on CloudWatch. And if you're using the third-party monitoring like Lumigo or Epsagon and so on, this price model sometimes is really tied to the number of Lambda invocations. So just by thinking how to decrease this, you also decrease your invoice. So one of the aspects is to write fewer Lambda function and use direct service integration. We will explore this. Another part is just to write less infrastructure as a code, for example, by relying on the frameworks which provide you these building blocks. This is like Amplify, this is serverless framework components. So there are solutions that give you some kind of abstractions. So now we will look into the examples of several architectures, and we will here see that we will touch upon all these popular serverless services of AWS: API Gateway, HTTP API, Step Function, Event Bridge, Lambda, DynamoDB, and so on. So I will explain the things in short. There are a lot of links below, so you can try things out on your own. You can also contact me. We will just talk about how to integrate all this stuff. And we will start with the API Gateway service integration. So generally, you may call Lambda from the API Gateway, and then Lambda can call other services like SQS and so on. But if you simply path the data to the other service that they only transport it but not transform it, it doesn't make sense just to write Lambda for this. You can use API Gateway service integration, and there are lots of services added all the times. In this example, you simply can just select DynamoDB. And for this, and one example from our from our application at IP Labs. So we have product groups that we offer, and we would like them to have the unique ID. So we have a lot of environments, but just we don't want to have duplicate IDs in case we need to test something or set up something locally. And for us, that was the discussion how to do this, and we integrated API Gateway with Amazon DynamoDB, which has the possibility to generate this ID. And it works by just selecting DynamoDB as a AWS service and simply providing this velocity template there. We just say the DynamoDB, what we need here is just simply just increment the sequence number and return this. of course, it has the price that your logic moved from the Lambda into this velocity template. And of course, you have to think about how to test this velocity template, which becomes not very obvious, but there are projects like the link below, API gateway, mapping template, and so on. So probably there are others, but generally we saved on Lambda and integrated DynamoDB API gateway with DynamoDB directly. And you can do this with a lot of services. So the alternative to API gateway, HTTP APIs, and what they offer storage first service integrations. So, and they solve the problem that in case of API gateway, you needed to use the velocity template. For HTTP, this service integration, you don't need this. So, you integrate the services like event bridge, Kinesis, SQS, app config, and step functions directly with HTTP API, and yeah, that's really powerful things. And we will see that this pattern all the time with AWS services, but we'll also explore other patterns. So now we will come to the event bridge, and here's also the same story. Event bridge, like event bus, which decouples consumer and producer, also offers you two different kinds of integrations. So first of all, AWS own service integration, like you see here, Amazon SNS. But if you just would like to see the whole list, this list is it's very huge. So for the put target of event bridge, you can use nearly every service that you would like. So also API gateway, DynamoDB, SQS, and so on. So the list is very, very huge. But the real power of this API destination comes with this stuff that you can integrate also software as a service providers. Yeah, with the same logic. So you can plug PagerDuty, Zendesk, Slack, and so on. And this works by simply calling invoke HTTP request, and the event will be delivered as a payload to this request. And you can use get and post and so on. You can use even input transformers to change the payload format to match your target. So very, very powerful things. So especially if you would like to integrate event bridge, for example, with the PagerDuty alerting system. So a lot to explore. Nearly every a lot of system may be integrated. You don't need this webhooks and so on. So yeah. Another pattern with event bridge, it provides efficient mechanism for filtering and routing your events. So in this case, just we apply the rule that the consumer receives only the events where the source will be equal to custom my ATM app. So you can also filter on all your attributes that you have, and of course it's just much more powerful as to receive every event on the consumer, pay for this, and then also filter on the consumer, which takes time and so on. So this filtering and routing is also very, very powerful and saves you code on the consumer side. Now we are moving to the simple notification service, and this is also here. You see the same pattern. So in this diagram, you see we have two kinds of events, like ordering events, order canceled and order placed. And we see kind of visitors event, product page visited. And if we are using Amazon SNS topic, we can filter on the attribute payloads. So you see here, we're simply filtering on event type. In case, for example, of order events, they go directly to the Amazon SQS queue. And for example, in case of page visitors, we simply calling Lambda. So this is also filtering for the SNS part. What was added also for the SNS, it provides also lots of integration and provided from the nearly every beginning, but now they added the integration to the Amazon Kinesis, which in turn can be integrated with analytic services like S3, Redshift, Elasticsearch, and so on. And what this enables you, for example, on the S3, you can back up and just back up your events for audit purposes. And in case they are on S3, you can then use Athena to query this bucket. You can also just use Elasticsearch and build your dashboards with Kibana. just for indexing all these events and so on. So also very, very powerful integration nearly without any code. And you can also use other monitoring systems like Datadog, New Relic, and so on, also to build the dashboards on their side. So moving forward to the step functions for building our workflows and states and so on. And that's the same story as we saw with Event Bridge, but also with API Gateway. Lots of integrations are provided. Yeah, more than 20. It's been more than 20. But now currently, I think released 2 weeks ago, you can now quote nearly all the services, but more than 200 services directly from your state machine. And how it works, you see this format. So you write this integration to this format: service name, API action, and optional service integration pattern. So in this example, we're simply calling S3 copy object operation. Yeah, that's very easy to use, and you have to pass parameters, of course, for this function. And the second function is for transcribing the same stuff. We are calling directly AWS service here. This is the transcribe service and start transcription job, and then passing some parameters. So with this, I just was waiting for this for years. Now we can embrace nearly all the AWS services from the state machine, eliminating simply writing Lambda function, which does nearly the same, calling this stuff in the Lambda function. So now we will be moving to kind of different pattern that we will see. And this one is kind of providing visual tools for dealing with services. And this is Step Function Workflow Studio, introduced several months ago. And what the challenge with what is the challenge with the step functions? That you need to understand Amazon state language in order to write all this code. And this is kind of DSL, domain-specific language, and it takes time just to learn it. And with this Visual Studio, you can simply drag and drop events, and you see all the needed information. You can select all the stuff. What is just what is the job? What's the task? What's exactly doing? You have all these choices, and it really simplifies working with this, and it's really, really fun. So I can only encourage you to explore this. So another pattern is Lambda destination. So yeah. In case of asynchronous calls, sometimes in case then, for example, the error is thrown, we need just to log this, and the popular pattern is to use SQS that data queue. Previously, it means 1 year ago or 2 years ago, there was only the possibility to write this code in the Lambda itself, and it's repetitive. So in case you need just to react on success, you had to write like on success, and then the logic that you need to provide in case of failure, you need then to send the message into the that letter queue. Yeah, with asynchronous Lambda destination, and the same code maybe just for all the Lambda functions, because you just react in case of errors the same. Yeah, just using the same that letter queue. And here, just all this stuff moved to the configuration, and now you can just select on failure, on success, and then simply select the services on the right which are supported for this destination, another Lambda, SQS, SNS, or Event Bridge. So also very powerful thing, and just removes a lot of duplicated code. So another pattern, now we'll be talking a bit about DynamoDB, and this is the similar story as with step functions. Yeah, now with the Workbench, there is a visual tool that will help you just to model the data, see the data visualize, so the visualize the data, but also building the queries. And I think it's in the early stage, because I think that the biggest challenge adopting DynamoDB is adopting single table design. And I think the tool is not there just to help people which design the relationships, just to move this to single table design, how just to help. But anyway, this is the step in the right direction, and helps people embrace DynamoDB, which I see a lot are struggling with. Another task which may often be done with DynamoDB if we need just to export the data. So prior to this integration, direct integration to S3. Just in order just to get the data for some purposes, we needed to set up data pipelines or Amazon AMR, and then use DynamoDB streams just to get the data. But this solution requires building custom application. It's also heavily using the read throughput of your DynamoDB table. So it's reducing your throughput. You're paying for this, and also just it had maintenance and operations cost. And now you can simply directly integrate S3 to any point in time recovery from the last, I think, 35 days, but you have to enable point in time recovery, and then all your data will be exported to S3, and then the same game you can use then Athena to just query the data and do something useful with this. Now we'll be moving to Amplify framework. Probably everybody knows that just the framework for full stack web development, but also mobile app development and so on. There are a lot of frameworks, web frameworks as well as mobile frameworks are supported with this. And also the same story. This model, the relationships with Amplify may be just also take time. And with this Amplify admin GUI, you just can do exactly this. Just you can model your relationship, you can query. You know that you just the GraphQL protocol will be used, so you can just model all the stuff. Also very, very powerful, and just make the onboarding easier. And another stuff which came earlier this year was just Amplify Managed CI/CD. And the essence is you simply select where your code live, either GitHub, Bitbucket Cloud, I think is supported, not the Bitbucket server, GitLab, AWS Code Commit, and so on. And by simply providing repositories, you will get all these managed pipelines. And in the end, just you will have the link just where the stuff is deployed. Of course, the questions arise, do you lose some flexibility just only using all this build, deploy, verify step from Amplify? Maybe yes, but generally the pipelines in many cases look the same. You just give your source code and everything else. You just want to build, you want to test, and so on. And this is kind of new direction, managed CI/CD, and just we are not dealing with all this pipeline stuff. And Amazon is very powerful there. So also please check out this, and also SAM serverless application model goes also into the same direction. Now we'll be coming to something new that was released last week, and this is Serverless Cloud Preview. So I took a bit of time to look at this, and it sounds promising, but I have my own thoughts on this. So the general promises is that serverless app development became very complicated, but general also cloud development, millions of services and so on. And sometimes we only need to make some API calls, REST APIs, GraphQL APIs, use DynamoDB as a database, use schedule tasks and so on. And what Serverless Cloud in the previous state gives you, just simply writing the code without any infrastructure as a code, and then everything else will be taken care by the Serverless Cloud platform. So this is one of the examples. I simply used it, subscribed this, and simply cloned the application. They only support now TypeScript and JavaScript, and they're currently also supporting that we're deploying into the AWS environment controlled by Serverless company. They will enable using our own cloud accounts, but currently it's only possible. And I cloned their to-do app. And what you currently see is simply we are importing via APIs, like API data schedule, and they are using their APIs. Here, simple REST calls like get. Here is delete, and so post. And with the data we are operating, with the data object we are operating on the model. In this case, this is to-do object, like creating new to-dos, modifying the state of this, and so on. On the first, it looks really promising, and I also caught myself several years ago. I don't want to maintain the infrastructure, but I also ask myself, do I need to write infrastructure as a code? Because it also takes time, and it's also a huge field and so on. And yeah, there are pros and cons. Now you don't see any S3 API. You don't even know what database is used behind. So it simplifies things. But on the other hand, I should also must ask myself the questions if this stuff will be deployed automatically into my account. And then, for example, I have AWS config, which relies that each workload needs some tag like author, and just serverless doesn't know this. Then the deployment may be rejected. How can I just change this? And I will change this. I will write kind of infrastructure as code. Yeah, it just doesn't matter how it will be translated. What will happen if the IAM permissions are not fine granular? Yeah, how I can change this? So in case it's not enough what serverless cloud provides me as an abstraction, how we can merge this stuff. So a lot of things are there. Also, like monitoring, alerting stuff. So how can AWS, so serverless cloud, decide what alerts are important for me? These are business decisions, and I just would like to adjust them. So it's very, very early stage, and it's difficult to say how it may go. It may work very well for some use cases, may become difficult for other one. But I think it's a huge area how to simplify all this stuff. But generally, personally, I think by writing infrastructure as code, but also dealing with this AWS services directly, I become a better engineer because I understand the services, I understand the constraints, the quotas, I understand trade-off. I don't know how serverless cloud may meet the decision if I would like to use SQS, or, for example, fan out SNS SQS, or event bridge, or even kinesis, because there are different trade-offs depending on just how many messages per second that I would like to process, and so on. And these decisions are business decisions. That depends on the business needs. So very mixed feelings, but I think it's very, very interesting, and I would like also personally see and follow how the things will be going. But generally, I agree that the serverless development may become a bit complicated and need kind of different abstractions to deal with. So yeah, the beauty of this is I can just develop locally and deploy within seconds to the new environments. So I can clone the stuff, and then I can deploy. I can here just create new environments for each developer for verification, and I can have preview. I can have my personal, and can have different stages. So it really works very, very well, and it's really, really easy and very quickly. So, but yeah, we will see how the things will develop. But check it out. So the common patterns that you saw are direct service integrations to reduce the amount of code written. So we saw this at API gateway, HTTP API, step functions, event bridge, SNS, amplifier. They are all follow this pattern. We see another pattern providing Visual Studio just to reduce the cognitive load. Step functions, amplify, DynamoDB do exactly this. Don't need to learn very deeply their cells and can model quickly. We see that the CI/CD pipelines will be automated and can be created easily. And the last one, we see first steps, and I call it first steps in interpreting infrastructure from code with serverless cloud. So I think that the whole purpose of all this stuff is just what Werner Vogel told us, that how the future of the developer will look like. All the code you ever write is the business logic. And all this step help us just to go into this direction, but I think that's a long way to go. So generally, using serverless ecosystem with the right engineering practices, I would like to spend several words. We will significantly reduce extraneous and germane cognitive load, especially extraneous, and especially we will reduce the amount of code written and also the amount of dependencies. So just by using API gateway and Lambda, we just don't manage execution runtime. We don't manage any web application server like Tomcat, and just we don't need to update it, upgrade it, and so on. But the word of caution about serverless ecosystems, so reducing dependencies doesn't mean that you own nothing. You still own things, but generally simply less. So even Lambda runtime, language runtimes version will be retired and will be deprecated. We saw this with Node.js below 10, and now Oracle GDK is Java 8 Oracle GDK is also deprecated, so everybody needs to migrate to Java 8 Amazon Corretto, and so on. And sometimes in the future, only Java 11 will be supported. The same stuff is with the database, Aurora with Postgres and MySQL capabilities. We received the message that Postgres 9.6 will be retired. Perfectly fine, because the current version is, I think, 13. So this 9.6 was 4 years ago, and the AWS cannot manage all the stuff for you in all possible versions. So you still own things depending on what you are using. Probably have less trouble with DynamoDB, because just the things will not be retired, or I don't see currently a lot of things that need to be changed if you are using AWS managed serverless services. So plan and execute upgrades continuously and iteratively. So just don't get stuck with all these past versions. That is also valid for serverless. So only several words. I know I'm running out of the time, and you probably have questions how to be successful with serverless. So let's focus on software delivery and operational performance. So how to do the things right. It's also important to do the right things. And the thing here is wonderful book, Accelerate, and you see how to measure success. So focus on these 4 key metrics: deployment frequency and lead time for changes is for the speed, and time to restore service and change failure rate is for the quality. It doesn't relate to serverless, it relates to the engineering as generally, and just the companies don't trade off quality for the speed. So you see that the elite and high performance doing deployment very often, and so on. And in case, strengthen software delivery and operational performance. So you see a lot of stuff what may help you to become to deliver the operational excellence. Cloud is one of the aspects. You also see code maintainability. It relates to the evolutionary architecture, where the serverless may help by owning less. Loosely coupled architectures, serverless, the same story. It's simply they're decoupled, event-driven by nature, and so on. Disaster recovery, all these best practices. So invest heavily in this, and then you will see that things may improve. One of the examples, for example, time to restore service. You have all these blue-green deployment possibilities and canary deployment with API gateway and Lambda aliases and stages and so on. So check this out. And probably only the last 2 words. What are the best practices? What I see working the serverless, there is kind of co-evolution of practices. It's logical. If you cannot use NoSQL database the same way you use relational database. So the same things you need to apply different paradigms using serverless. So true DevOps is one of the things. So devs and ops working together with one team, complete infrastructure automation. It's true for the whole cloud, but especially for serverless. Chaos engineering, FinDev responsibilities in the team. So your teams may have a view to the invoice, because invoice pricing, just decrease pricing is the same feature like performance and security. You need to prioritize things, and then developers need to understand pricing of the services, and they also need to have access to them. And also several others. We saw this with Google Cloud. Each team or even developer may have its own test account, even for the feature. We see only minimal local testing, only for quick functional tests. The people test directly on the cloud, on the staging, but even better, they adopt testing in production, because the real user behavior can only be seen in production. So you will see all the quarters and so on. So with this, that was the last thing I wanted to tell you. So if we have several minutes for the questions, I will be happy to answer them. Thank you very much.
Thanks for this great presentation. So I think we really enjoyed it. Aaron, any words? I think you're still on mute, which is
all good.
Sentence of the year.
Yes, exactly. That's right. I think it's just showing that there's a real maturity going on in the serverless ecosystem. I think that it is really starting to become a why not, like not a why should I use it. It's now why aren't you using serverless. It really, I think, is really at that stage where all of the pieces are falling into place across AWS in terms of integration of services. I mean, that step function change that recently happened is really like a game changer, because before you had Lambda hell because you were writing so many Lambdas to do very basic things, and you had to maintain them, and you would never change them, and then they would get versioned. And so, yeah, I think that is really like, it is really becoming so simple. It was great to see, Vadym, that you kind of highlighted that fact, and you highlighted those things that really only happened in the last month or so, right? Which is really great to see. So.
Yeah, thanks for this great presentation. I think whenever I do a serverless workshop in the future, I will just show this video and then start the workshop. So, okay, all the basics are done. So now we can start into the deep dives. I really liked the step functions thing that you brought, this interesting thing, because it's really, really great, especially with EventBridge. I had this with the project right now. It's like, yeah, having 2 steps in a step function, like, oh, there's an event coming in, do an API call in step functions, no code written at all.
Yeah.
So this was really
power and magic. Yeah.
So,
thanks, Aaron. Thanks, Thorsten, for the invitation.
Yeah. So
nice
one question that came to my mind. So there were these Lambda destinations. What do you think? What's the benefit of Lambda destinations versus just orchestrating and using a step function?
Yeah, if you have workflows, then of course, then use step function. Then it's simply, yeah, if you need to orchestrate, then use the workflows. But sometimes it's just simply put event into the event bridge, then call Lambda function. It may be enough. Yeah, and then sometimes you need to react on errors in this case. But of course, if you have workflow, if you have this lot of asynchronous step, then probably workflow orchestration may be a better choice for me.
Okay, yeah, because I'm afraid that people will just chain Lambdas together using destinations and rebuild step functions. So,
oh yeah, that's probably
yeah. But yeah, thanks for the great talk, and yeah, thanks for being here. Hope you stay around, watch the other talks, see what we have.
And hope to see you in person next year. I missed it for the second year. I have the T-shirt from Hamburg. It's 2 years ago, so I'm not ashamed to have it, because
it's a last real one. Yes.
Yeah. So I'm looking into the future. This is a merchandise for Road to Reinvent. I'm hoping that this is happening well. So let's look into this. So thanks again, Vadym.
Thanks.
I will now remove him from the stream because our next speaker is here, and we will go directly into our next session.
I did want to quickly say, just to mention the community Slack, as we bring in the other speaker.
Yeah, go on. We just lost the speaker. I think that's happened. What's happened on track 1 is now happening with us, but it's live and it's in Germany.
Exactly. So, I just wanted to make sure that there's conversations happening over on the AWS Community Slack. So there's the AWS Community Slack DE. If you're looking for that team, please join that. There you go. Perfect. There's a link on the website. Please join that. And there's conversations going on there, and the speakers will be there. So if you had a specific question that you wanted to ask the speakers, that's the place to do it, right? That'll be the easiest place, and you can do it also on YouTube comments. But I think the conversation, the sort of more meaningful conversations, will be happening over on the Slack channel.
Yeah, perfect. So welcome, Dan. Our next speaker talking about Who Am I? A Vision for Voice Authentication. I will not name the service that it's targeting, because otherwise a lot of devices next to me will start talking to me. But I think it will be about some Echo devices. So I will go ahead and share your screen when you're ready. And currently I see...
Yeah, I'll start right now. Just a second.
Perfect. But it's also a wonderful image, so we can look at this in the meantime.
Okay.
So
great.
Yeah, happy to have you here, and the stage is yours.
Thank you. Thank you very much for the invitation. I also had the privilege of speaking here last year, so I'm thrilled to be back. Can everybody see my screen okay?
Yeah, everything's working perfect.
Excellent. Okay, great. Just a few words of introduction before we dive into the meat of the presentation. My name is Dan Fitzpatrick. I'm originally a web programmer, and I've been doing that for well over 25 years. I started programming before the advent of CSS, just to put it into historical context. And a few years ago, I got interested in the programming of speech interfaces and obviously Amazon Alexa. So it kind of took off from there. And right now I have 2 roles with the Reply group. But before I get into that in any more detail, I'd like to tell everybody I'm working with my assistant today. Her name is Alexa, and let's hope she doesn't have any stage fright. Alexa, ask Reply Voice ID to identify me.
May I introduce Dan Fitzpatrick? He tells everyone he works at TripleSense Reply in Frankfurt and is the lead for the community of practice for voice machine interfaces, but he really makes burgers at a fast food restaurant. Anyways, do folks know the story about you in the karaoke bar?
Alexa, stop.
Oh no, I was just getting to the good parts.
So that's a little bit about me. And since the 1st of January this year, I have the privilege of leading a new business unit here at TripleSense Reply in Frankfurt for conversational solutions. We do a lot of work with Amazon Alexa and with Amazon Web Services in general. We have managed to become recognized as a partner agency for conversational design. You can find us on the Amazon webpage. And also, one of the things we do here at Reply is because we are a consortium of companies all over the world, we have networking structures within the Reply group called communities of practice. These are think tanks to get people talking and working on one subject all over the world together who otherwise might not meet up. And I have the privilege of leading the community of practice for voice machine interfaces for Reply. So, enough about me and about this topic. I want you all to listen very, very carefully, because obviously getting this speech together, we jumped back and forth between German and English a lot. And the word authentication in English, in German, is Authentifizierung. So if any of you hear me say authentication in English, that's one gummy bear point less for me, because it's a mistake I keep making. So let's get into the background of this presentation a little bit more. I want to tell you we're going to be talking a little bit about risk management and what is multi-factor authentication. Why do we do it? I'll give you some examples. We're going to be going into the history of biometrics to find out how do voice prints work and how can computers identify me by my voice. We're going to be talking about the physiology of human speech and the algorithms which can determine who I am by the way I speak. But as with any authentication method, there are ways to attack them. So we'll be talking about spoofing and how people attack authentication methods, biometrical authentication methods. But then we're going to go into the solutions and the defenses against those attacks. Moving along, I'm going to show you a little bit about my vision for multi-factor voice authentication. And you might be saying, well, it gets used every day, for instance, in call centers and things like that. But we go one step further. How did this talk come to be? Well, one day last summer, I was sitting on a hot day at the beach, and I thought to myself, I'd like to go up to the kiosk in the corner and get myself an ice cold beer. But I didn't have my cell phone and I didn't have my wallet, so I couldn't have anything to drink. While I was thinking about that, I came up with the vision, an idea. I said, what would happen if we could simply authenticate ourselves with our voices, not just in a call center or to my financial institution over the phone, but during everyday mundane transactions? That, for me, would be a tremendous convenience. talking within the reply group, I spoke with a buddy of mine who's a partner at Spike Reply. They do cybersecurity in Cologne. And he said, that's an interesting idea, Dan. And a week later, he called me back and said, thank you very much for the distraction, which I certainly can't use. But since you talked to me about this, I can't think about anything else. So the Reply Corporation, we've started a working group revolving around voice authentication, and we hope to literally move this technology into an everyday use scenario. If you have ever called up a call center and had a problem, maybe you got asked a couple of extra verification questions during the process to extend a subscription or to do the pre-verification with your bank, think to yourself the next time you're on the phone about two things. First of all, they often ask you, we may record this call for customer service purposes. Is that permitted? They may be taking a voice print to be able to identify you faster the next time around. And if you ever use one of these systems and you have a cold and can't speak properly, listen carefully. They just might send you through another authentication method and ask you to enter a PIN number, give them your date of birth, anything along those lines, which would not necessarily be the case otherwise. People have been asking me, well, human beings have so many ways to identify themselves. Why don't we just take a thumbprint? My answer to that would be, well, you can steal a thumbprint, and literally you can steal somebody's thumbs. Chop, chop, take it right off, and then you go to the bank with that. It's not as simple as that, obviously, but these forms of biometric identification are not as secure as voice prints. We'll be getting into that a little bit later. Risk management is literally the science of weighing possible financial loss or other kinds of damages against the hurdles I need to authenticate myself. Thinking about it, if I go to the bank or if I go simply to buy my groceries, I have to validate myself with my bank card to pay for my groceries. Well, the bank card is in and of itself a multi-factor authentication. It has a chip. It might have an RFID. It has a signature on the back and maybe even a picture. And it also has a PIN number. But if you're at the cash register and you just want to buy something for a few euros, maybe it won't even ask for the PIN number. That's a good example of risk mitigation or risk management. The bank has decided, I'm more than willing to risk that somebody has stolen Dan Fitzpatrick's bank card and not worry about the PIN number so I can get him through the checkout line a little bit faster. But with the same bank card, if you try to withdraw 3,000 euros from the money machine, the chances are the bank won't let you even with your PIN number because there are safeguards in place. They make you call the bank and say, hey, I need to make a large withdrawal. Can you help me out with that? This is risk management. What risk management does is it detracts from the customer experience, giving me inconvenience if I want to make a large transaction where financial damage might take place in case of fraud. So my vision would be to say, hey, my name is Dan Fitzpatrick. I want to access a parking garage. I want to pay for my groceries. I want to buy an ice cold beer at the beach. With transactions for a relatively small sum of money, I think it should be possible for me to just pay with my voice. There are many, many different ways of identifying human beings by measuring them. The science behind that is literally called anthropometrics. It comes from the Greek anthros for Mensch and metriki, measurements. Common methods of that are obviously fingerprints, facial recognition algorithms, voice prints. We'll be talking about those in quite some detail, and obviously more detailed recognition methods like retinal scans or even vascular scans. But if you'll notice, 3 of these 4 methods are visual in nature. And that is a problem because if it's a picture, if it's visual literally, a picture can be copied much more easily than can a voice. A picture is nothing but a static representation of one moment in time. You take my thumbprint, you take a picture of my face, you scan my eye. These are all static representations. But as we will determine in just a minute, a human's voice is a dynamic representation over a period of time. Let's take a look at biometrics. We'll go back into a little bit, give you a little bit of history about it, take a step back, and just to underscore the factor that this is not something new. Literally 500 years before Christ, ancient Babylonians were verifying transactions and legal documents on clay tablets containing fingerprints. That's how long ago biometrics have been used. Moving along, the Chinese obviously use fingerprints or other types of seals called chops to verify the identity of significant legal documents. And then the Persian book, I've forgotten the name, Jamal al-Tararik, I think is the name of the book, is a series of chronicles written in the early Middle Ages. And it comments deeply, going into some detail about the practice of identifying people with their fingerprints. So even throughout the history of human science, we have realized you can identify somebody, determine importance, relevance, or prevent fraud by using biometrics or measurements of human life. The scientist Gallatin in the last 2 centuries ago first identified a system of classification using fingerprints. And he said, well, I understand that the fingerprints are unique from person to person to person. Why don't we develop a classification system of loops and whorls and ridges to say, hey, this is how we can quantify a fingerprint to better compare two of them. The classification systems for fingerprints aren't the same as for voice prints, but they do use classification systems and algorithms for identification. Later on in the 1970s, we have a very, very important milestone for semi-automated facial recognition. I think it was created by a Swedish professor, and it was a model of the physiological components which make up faces. So we have known for some time, and the first prototype, of speaker recognition and biometrics was at the end of last century, obviously by the American Defense Department. So we have known for some time there are many ways of determining how to identify human beings by measuring them. Let's move on from biometrics in general and obviously static biometrics, which are images, to voice recognition. It is a robust and powerful means of recognizing a human being. It is one of the most unique forms of identification I can produce. You can measure up to 150 characteristics of a person's voice, which is, I think, very, very interesting. Not just physiological characteristics, but it has your voice has acoustic patterns which reflect both your anatomy. So if you have a large chest, you have a deep voice, but you can also have learned behavioral patterns which help to identify you, like a dialect, an accent, maybe a speech impediment, anything along those lines, which make you more identifiable than the simple sound waves of your voice as made by your body, but the way you speak as well, the idioms you use, where you come from, your dialect, and things like that. As like I said, a voice print is much more complex than is just a fingerprint, because a voice print is a mathematical measurement taken over a period of time. And it gets more and more accurate the longer you speak. You keep measuring the voice involved. So what happens is, instead of taking a single image from 1 second, you continue the authentication throughout the entire process, and you can revisit it. You can re-authenticate somebody during a transaction by continually listening to their voice with a voice interface. So voice recordings are multi-dimensional patterns over a specific period of time, rather than a single pattern like might be a fingerprint, hence the robustness. This is also not new. Like we said, the 1990s, there were many, many technological jumps, but the late 19th century is when the first forms of voice print recognition, the first attempts were made to use that as a way to identify human beings. Believe it or not, voice print recognition can be up to 99.99% accurate. interesting anecdote here. When I was developing the material for this speech, we were contacted by somebody who works in the cybersecurity and customer relations department of the Commerzbank here in Frankfurt, who said, well, that's not entirely true. There are two aspects of voice print recognition. So I'm forced to make a little bit of correction here. You can certainly reach a 99.9% accuracy, but the more accurate you get, what you're trying to do is reduce something called the FAR, which is the false acceptance rate. So I could say, hey, my name is Mary Poppins, and the system accepts me as Mary Poppins. That would be a false acceptance. We're trying to obviously avoid those. But the higher the FAR is, the rate, the percentage rate of the FAR, if we get up to 100% accuracy, it's also a higher rate of what we call false FRR, or a false rejection rate, meaning that if the more accurate the system is, saying that I am not Mary Poppins, but I am indeed Dan Fitzpatrick, the more often the system will say, no, you're not Dan Fitzpatrick, please try again. So having 100% accurate biometric voice print recognition is difficult because it comes at a cost of false rejections. Just to put that into context, we had some interesting discussions there, and it's also why we're going to, for our visionary application for voice recognition, only use biometric recognition for one factor of a 4-factor voice authentication method. And I'm really, really looking forward to the discussion after this, because every time I talk about this subject, I learn more about it myself. Speech production, like I said, is obviously a biometric. It is a physiologic event which I produce with my body. Let's take a closer look about how this works. Our voice, a vocalization, consists of many different components coming together to create a unique sound. I have the vocal cords in my throat, which vibrate. They vibrate either loudly or softly, and they have a pitch. Is my voice high or low, depending on how I'm talking? So that vibration is one part, it's one component of my voice. My mouth, my throat, and all the cavities in my chest have they pick up the vibration, and from there we get what's called resonance, just like the corpus of a guitar might, or a piano. So you hit a key or strum a guitar to produce a vibration, and then the body of the instrument makes the resonance, it carries it out. And obviously getting up into my mouth, there are many, many other little bits and pieces that work there. It's my tongue, my lips, my teeth, my nose, my palate, all take this vibration and the buzz and put them together with hisses and popping sounds called plosives to make my complete vocalization. So there's a lot going on here to take into consideration. A hiss might be something like an F or an S. And obviously, if I'm talking, I'm saying the difference between a pop and a bop. Those are explosive sounds. Those are called plosives. So taking a voice apart, you get a lot of different components explaining how the whole thing works and fits together to my unique biometric voice. The technology involved is obviously machine learning pattern recognition technology these days. The algorithms involved, they look for features in the spoken word. There are many, many different ways to put it all together. I can't explain them all to you right now for two reasons. First of all, we don't have the time. And second of all, I don't feel proper with the necessary technical expertise to go into depth. At any rate, it uses things like hidden Markov models, Gaussian mixture models, matrix representation. We'll be getting into that maybe a little bit. At any rate, it takes my voice and breaks it down into its individual components to make algorithmic comparisons, something which we call linear predictive coding. We'll go into that in a minute. But I have taken two things or three things here which I'd like to go into a little bit more in depth. One of which is called a cohort model, meaning if I make a vocalization like I say a C, and then from that I make a K, like C-A, and then an N, I have the word can, we're starting to get meaning out of that. But then if I attach another syllable to that, candle, then it takes the individual syllables, puts them together into words, and then puts those words together to gain meaning. In this case, if it was like a natural language processing algorithm, but it's also used in speech recognition. We also talk about something called world models, which are more or less attributive associations between words themselves. So if I said can, it might mean something like I can do something, or it might mean something like a can of beer, getting back to the ice cold beer. So cohort models and world models, they take the associations between words, putting together to get meaning, but we can also take the words and the vocalizations I make and put them together for comparison with something called linear predictive coding, which enables us to speak. Linear predictive coding more or less breaks my speech down into its individual components so that we can put them back together and make sounds. It makes a mathematical model of my voice to predict in the future. So, okay, if we get a voice print, we can predict how it should sound, make a comparison with the existing voice print of Dan Fitzpatrick. So he gets his ice cold beer, everything matches, and it's fine. Moving along, linear predictive coding, what it does is we've made a mathematical model of my voice print, but it doesn't take all the little bits and pieces that might be compared. It breaks it down. And it takes the basis of the vibration and the resonance for the initial comparison, making a model of that. And it kind of filters out other components of my voice, like the sibilants, the hisses, and the pops, which we're making. To give you a better idea of how this all might work, I'd like to demonstrate it with you right now. When this filtering has been completed, what we have is it removes things from my voice which are not necessarily needed for the voice print, and makes a comparison with the so-called residue, that everything that's left over. Very, very easy. I hope, especially in times of this pandemic, that you all have clean hands. You've been washing them several times a day, because you are going to take your thumb and forefinger now, stick your tongue out of your mouth as far as it will go, and then grab it between those fingers and pull it out. Having done that, you can say your name. Dan Fitzpatrick. What I've just done is broken my voice down for linear predictive coding. And what you heard was more or less my voice filtered out of all the little bits and pieces, the consonants and the consonant sounds I make. And you just heard the vowels, which is the resonance coming from my body, to give you an idea of kind of how linear predictive coding works. It takes the residue out of my voice and compares it to the voice print with many, many different characteristics to come back and give me a match or a rejection. But I was talking about false acceptance rates and false rejection rates a few minutes ago. Let's talk about spoofing now, because there are dangers to authentication. There are 4 basic types of spoofing attacks which can be conducted to try to impersonate somebody else. And impersonating is becoming a bigger and bigger part of fraud cases in the financial industry. It is not necessarily a really serious threat, but banks are starting to register increased attacks. And if you believe it or not, the classic telephone fraud, where maybe we try to make a phone call to a corporation and I impersonate the chief executive officer of the corporation. I say, hey, I need you guys to wire 100,000 euros to a Bahamian bank right now. It's very important. There have been recorded cases where people have used speech synthesis to try to replicate the voice of the person, the target that they are impersonating. Obviously, I don't need to go into things like internet fraud and digital fraud. It's a part of our daily lives. At any rate, there are dangers to authentication. I just talked about the first one. It's impersonation. Anybody who's ever watched a comedy show with somebody who is impersonating maybe a political figure or a movie star knows how entertaining it can be. But you also know that a talented artist can really impersonate not only the voice, but the accent and the mannerisms of a target person by changing their voice physically. So impersonation is one way which could be used to attack a voice recognition system. Another way is the replay attack. I don't really need to go into a lot of detail here, but let's say I'm in the line at the beach and I want my ice cold beer. I've just authenticated myself very well, but there's somebody behind me who's just as thirsty as I am, and he thinks I'm really smart. I'm going to use my cell phone to record this guy's voice, and Dan Fitzpatrick doesn't know it yet, but he's paying for my beer. So a replay attack would be a recording of your victim's voice. You replay it to the bank, get the authentication, and there you go. Moving along, we talk about speech synthesis, which we can use to construct your victim's voice. This is something which is going to play a bigger and bigger role, not really fraud, but speech synthesis in audio branding, where you create the voice of your dreams. So let's say the voice of my dreams happens to be Dan Fitzpatrick because I want him to pay for my beer. Then I would use a special algorithm to imitate his voice using speech synthesis and make an electronic copy, which I can have say whatever I want. Moving along there, we have something called voice conversion, which is similar to speech synthesis, but it takes my spoken word and converts it instantly into the voice of the target person whom I'm trying to impersonate. So I can change my voice electronically on the fly, trying to commit fraud using somebody else's voice. But there are authentication methods which can be used to combat these spoofing attacks. So let's go into that in a little bit. We're going to be getting a little bit into artificial intelligence, maybe a little bit more about biometrics. I think it's a really fascinating field. It's something I've learned a lot about in the last few months and thinking about turning this vision into an actual reality. We can use machine learning models or deep learning models to do what's called a liveness check. I didn't know that this was something that existed up until a few months ago, but what I can do is by doing detailed analysis of the noises of the speech, I can make a pretty good determination. Am I speaking to a live person? Am I having a conversation with a live person? Or is it something which has been recorded? For instance, if I'm having a conversation, the waves of air and sound coming out of my mouth make physical impact noises on the microphone depending on its proximity. So the actual airflow coming out of my mouth will be hitting the microphone, and that would be one way of determining, am I speaking to a live person or is it a recording? Another way is using the peaks and valleys of my voice to find out, is this an actual live person? There's also something called an echo detection. So when I'm talking to a voice interface, the voice interface can send sound waves out, which should be echoed within my speech. If these echoes have been altered or are missing, I know I'm talking to a recording and not a real person. Moving along from there, we have voice behavior analytics. This is a very, very interesting field of science. It uses emotion AI to listen to many different characteristics of my speech to find out, am I under stress? Am I lying? Maybe I am physically not enabled to make this transaction right now. So stress detection, for instance, measures the changes in pitch in my voice, because people who are under stress speak differently. They have different peaks and valleys between the lower parts of their voice and the higher parts. I can also measure the distance in time between the peaks of my speech. I can measure changes in the pitch of my speech. A calm person would tend to talk in a monotonous manner, and a person who is excited like me because I'm nervous giving a speech to everybody out there might have more modulation in their voice, having higher peaks and lower valleys, changing more dynamically over a set period of time. There are many other things involved. Those are just two of the bigger examples for voice behavior analytics. It plays a big part in our theoretical visionary application, which I'll be showing to you in a moment. Here's something else which is really interesting. So let's say you're at a supermarket and you want to pay for something with your bank card. And instead of entering in your PIN by, those little number pads they have where you kind of hide your hand and look over your shoulder to make sure nobody's watching you, what would happen to the supermarket if they said to you, okay, Dan Fitzpatrick, if you want to pay for these groceries, shout your PIN across the entire supermarket by speaking into this microphone? Well, nobody would do it, because then I would be telling people what's my password. What, however, if I could generate a method to make what's called a one-time password, a password which is contextually based, only used once with no further meaning to the folks around me, and would never be used again. There's certainly ways of doing this. One theoretical way would be to contact your payment provider or your financial institution and talk about a secret object with them. So let's say your secret object would be a pirate ship. I say, okay, folks at the bank, my secret object is a pirate ship. Only you and I know about the secret object. What would then happen is using, for instance, a system like Amazon Comprehend, which is sentiment analysis using semantic networks and things along those lines to determine mood, you could take this object and using the right ontological domain, you could generate maybe 1,000 questions all revolving around this secret object. Obviously, yes and no questions aren't as secure as open questions. So if you say, okay, is your secret object made out of granite? I'd say no. Well, anybody confronted with this question would have a 50-50 chance of getting it right. But you could say, tell me one letter which exists in your secret object and one which does not. Now we're getting a little bit more into detail, more difficult to spoof. Is your secret object made of wood? Does it drive? Those are yes or no questions, but we can ask open questions. Have you ever been inside your secret object? Contextual, but it's still a yes or no question. I have lots of examples in the back of my head, but at any rate, maybe you'll come up with some more later on, not just a binary question, which a yes or no answer, but there are also contextual answers you can give, which will help people determine, is this somebody who knows what the object is about, or is this person lying and trying to commit fraud? And as I explained earlier, using multimodal biometrics, we can record a voice print. And the voice print would be one bulwark in our system. So if we have here a 4-factor authentication system, which is using one medium, like your bank card with many different authentication features, your voice has them too. And coupling all of these together should provide us with a level of security, getting back to risk management, which would allow me to sit there and buy a beer at the beach because it costs 3 to 5 euros, no big damage. I don't have to have my wallet. I don't have to have my cell phone. I can just enjoy my ice cold beer. One more thing before we move along to the next topic is contextual plausibility. Machine learning algorithms won't be just listening to my voice, but they might be listening to the background information as well, looking for contextual evidence. So if I call up my bank and say, please, I need new credit cards as quickly as you can get them to me. I'm at the train station. I've lost my wallet. But the machine learning in the background, listening to the telephone conversation, hears waves breaking in the background and seagulls screaming in the sky. You might think, wait a minute. The contextual plausibility does not match up. Let's ask this guy another question. So the challenge is to provide the people the convenience they demand while enabling automatic, touchless, unobtrusive, multi-factor voice authentication. Is it possible? Yes, it is technically possible, but it has yet to really take off. It has yet to be a mainstream technology. I think it's just a matter of time. I'm going to go into a little bit of detail now about how it might work. Let's talk, for instance, about one-to-one authentication versus one-to-N to kind of take care of a big concern you folks all might have and say, well, wait a minute, how much computing power is this going to take to compare my voice to 20 million voice prints to find out, do I have a match or not? Or maybe somebody's out there who has a very similar voice to mine. There have been cases of Face ID being spoofed, things along those lines. Well, what happens if I have a user ID or I simply say my name? Well, there might be 50,000 Dan Fitzpatricks worldwide, but what if I say my Twitter name is TerraFitz? Okay, that would be one word. We can identify that and start matching really quick instead of having to identify. So we do a one-to-one match instead of a one-to-N to speed things along a little bit. We'll do the liveness check, like I said, to prevent the spoofing with recordings. Okay, am I speaking into a microphone as a live person or as somebody playing a recording? We'll couple that with a stress test. Is somebody standing behind me with a gun saying, hey, Dan, pay for my beer, please? I've just illustrated how it can be done. all within the same voice print. Then we would have the passphrase authentication. So I say, hi, my name is Dan Fitzpatrick. My ID is so-and-so. I want to buy an ice cold beer. Okay, fine. What's your passphrase? Let's talk about that. And then obviously moving along from there, the last part of the application would simply do a voice print comparison. Is it possible? Yes. And we're going to do this in all different types of scenarios, calling up anybody in automatic voice recognition scenario. These things use voice prints already, like I've illustrated, but now we can give them a few extra layers of security. Standing at the automated teller machine, we're in the middle of a pandemic. I certainly don't want to start touching keyboards. Maybe I can just say, hi, Dan Fitzpatrick, my ID, my password, give me 200 euros. Going shopping. Who wants to dig for their wallet or their smartphone when you have hands full of groceries and maybe a screaming child next to you? Whatever. Simple things like car sharing services, pulling into a parking garage, authenticating yourself with an automobile. Most people have something in their hands when they're getting into their car. Traveler's ID, I think, would be a great scenario for something like that. You're at the airport, don't really need a passport, don't need anything else. You can say, my name is Dan Fitzpatrick and flight number, and let me onto the plane, please. Super. So what have we been talking about in general before we get into the questions and answers? I see that we still have plenty of time left. I'm really hoping to hear back from you about your feedback about this. Why and how? Voice authentication. In just a few short sentences, authentication measures are always a hindrance to a good user experience. So if I want to have a quick and easy shopping experience or a transaction, I don't want to have to authenticate myself. Let's say I was at the beach and I wanted to buy a beer, and they said, well, okay, Dan, I need to see your wallet. Oh, show me some ID while we're at it. Let's see how old you are. Oh, and I need to have your birth date as well. Then I wouldn't buy a beer there. I'd go somewhere else. I obviously understand there are need for high levels of transaction security. If I'm buying a house with a suitcase full of cash, I think I'd like to have them ask me a few more questions rather than simply accept the transaction. Risk management, like I said, is the science of weighing the cost of security against the potential damage involved. So I think for general transactions, it's certainly an acceptable risk for me to use my voice, especially if we have a robust series of algorithms checking many, many different factors about how I'm trying to conduct the transaction. Obviously, the higher the risk, the more authentication, I just said it, more authentication factors are required. So I don't think that will ever change, but that's what risk management is all about. But voice technologies offer the possibility of multi-factor authentication with one single medium, which I think is pretty special. Because if you are going to visit your Swiss bank account, you have to show them ID, you have to give them a signature, you have to do many different types of authentication. Maybe they will check your fingerprints. Those are all different media. The more media you have involved, the more the chance that somebody could break into the system. So if you just have one single medium, you have it with you all the time. There are ways, for instance, to continually update your voice print. Obviously, people's voices change as they age, just like you have to have your passport renewed or your driver's license. You certainly update your voice print with your identity provider every few years. But think of the level of convenience. Just everybody watching right now, how many little transactions have you done just today? Did anybody take public transportation? Did you buy some lunch? Did you go shopping? What if you didn't even have to take out your wallet for that, or any object whatsoever could simply speak? So here is some further information. I'm sure we'll be providing this stuff to you. Anybody who wants to get these links or information, if it's not provided, can certainly talk to me. I've done a lot of research about this topic, and I've been working a lot with Amazon Web Services and voice programming and things like that. So I know that these systems work and can work, and I really appreciate that you listened today. So we'll get into some questions and answers, but all this talking has made me kind of thirsty. So let's see if we can take care of that problem really quickly too. Alexa, Tell Reply Voice ID I want an ice cold beer.
Okay, Dan, I recognize your voice. Let's authenticate you. Does the name of your secret object have more or less than 7 letters?
It has less.
Tell me, is your secret object bigger than a cow?
No.
Transaction approved. Enjoy your beer, Dan. And folks, don't forget to check out our consulting offers with Reply Online Services.
Alexa,
I still
stop.
want to tell.
Thank you for listening, everybody. I hope you enjoyed the presentation, and let's dive into some questions and answers.
Yeah, perfect. Thanks. It was really great.
My pleasure.
Yes. So my first memory when listening to your talk was GoldenEye, James Bond. General Arkady Grigorovich Urumov at the Severnaya station. Voice authentication in James Bond in, what is it, the 90s or the 80s or whenever.
Exactly.
So yeah, it was already there, and now it's possible. Like lots of these things.
Yeah.
Yeah, I had a similar thing for the movie Hackers, where it's the voice is my password, verify me. That it's sort of a famous sort of voice, authentication thing from that movie. Yeah, so brought back memories.
Okay, I'd like to get back to the web interface so I can see the chat. Can I stop the presentation now?
Yeah, sure. Okay. But we don't have a chat online here, so okay. Let's see if we have only a cheers to you. So people are enjoying you having a beer.
Yes.
I hope next year we can have this beer together instead of at home. But yeah, so let's look if we have more questions.
I definitely don't want my t-shirt.
Yeah, so we definitely have no more questions because I think it was such a perfect presentation that there's no questions left.
I think everyone.
How can I buy it?
Yeah, exactly. I think everyone will have questions probably in half an hour or an hour when it's kind of finally sunk in. I think the amount of information it's just buzzing in my head. I think it's one of those ones that you don't realize the impact that something like that can have until you actually, you've kind of really thought about it and like the impact.
And we just got one comment.
Oh, super.
So one of the pitfalls that might be possible and how that could be tackled, like what if we lose our voice? Like, we have a cold or some things happen, or you party hard and the next day you're not let into your hotel.
Yeah, exactly. There is actually a really funny video on YouTube about somebody who just came back from the dentist and his house thought he can't get back into his house. Well, if you lost your voice immediately, like getting really sick or something like that, it might be kind of like losing your wallet, but then you also have other ways of doing the transaction. So you would be forced to take out your bank card. And, in worst case scenario, like losing your wallet, you might have to call up your bank and, assuming you can speak, say, hey, I need to do a new voice print, or we'll switch back to the other authentication methods.
Perfect. Yeah, I think it's open for improvement or like all technology, but it's a great vision to the future, and really, interesting. What's coming ahead. So what lies ahead, and what the future will be.
Just Reply has put together a working group around this topic. We have several master's students just doing their thesis about different technological aspects of it. But web services, software as a service for liveness checks, stress checks, and obviously voice print providers, it's all out there. I think what we need to do is simply create an application which chains these services together with a powerful semantic network. And then we would have, we would have a working model. And then obviously, for instance, every cash register has a terminal. Many of them have cameras. It shouldn't be a problem to put a microphone there.
Yeah, as I said, I think it will start with high-risk situations like banks where it's really needed. And then if the technology gets more used and gets cheaper by this, then finally it will be the beer at the beach.
Exactly.
So yeah, thanks again. And yeah, I think we will just move directly to our next talk. So I will remove you from the stream.
Okay.
I think you will hang out in the chat a little bit longer. So when any questions arise, just...
I will. I'm going to log on to Slack now too.
Perfect. Or just use the Twitter handle that's printed there.
Great.
So as we had him from Reply, I just want to thank our main sponsor again and just show a quick ad as we add our next speaker. Yeah, thanks again for Storm Reply for sponsoring this event. And with me now, Henning. And I'm really looking forward to this talk because it's about CDK. And whenever I'm not doing community stuff and organizing community events, I'm writing CDK code. So I'm really looking forward to this talk about how the anatomy of a large-scale CDK project, because it's always easy if it's demos, but it's always hard if it's live projects.
Exactly.
So, Aaron, any comments?
Yeah,
or should we just dive into?
Yeah, I think we should just get started. This is again like it's a good theme today. I think we've got a lot around authentication, and I think it's really good now to see some real kind of real world use cases of that, and also the CDK as well, right? So it's all the hotness right now, and I think it's good to kind of see some real practical experiences of people using it. So I think take it away, Henning.
Yeah,
okay, thank you.
Go ahead.
Thanks for having me back this year after last year's presentation. Might have been not so bad, so you have me back this year. So my talk is the anatomy of a larger scale CDK project, and as you said, Thorsten, we all have done many tutorials on the internet about the CDK, and it's always that easy to just spin up a few source code files and then copy a few Lambda files in it and then go away and deploy it. But what happens if you go large or larger? And that's what I'm going to talk about today. It will be a lot of stuff that is naturally to cover when talking about software development. So maybe I will be a little bit fast on some topics, but there's a demo repository on GitHub which you can always go back to and take a closer look after this presentation. So who am I? Hello, I'm Henning. I'm working for Storm Reply as a senior consultant now for 3 years nearly, and my day-to-day business is developing CDK solutions, serverless solutions for our customers. And that's where the experience and the topic of the talk comes from today. So what are we going to do today? So first we're going to talk about some prerequisites. Then, of course, what is this AWS CDK and what limitations and features it has. Then we talk about code organization, how to develop a larger scale app. Of course, CI/CD is always a part of a professional larger scale app. And at the end, we'll have a short conclusion. So the basics. I don't think I have to say much about this. If you're doing professional software development and don't use Git nowadays, you are not doing professional software development. So use Git. That's the main takeaway. It's distributed. It allows collaboration with your colleagues. It provides you hooks to have certain checks when working with Git. And of course, it's freely available online through different services like Bitbucket, GitHub, GitLab, even AWS Code Commit. You can choose. Okay, the first decision that we made here at Storm Reply when talking about the CDK is why we are using TypeScript. And it's very simple. It's these 3 points. And AWS CDK has its primary language is TypeScript. It's developed in TypeScript. and it allows you via the JSII compiler to generate CDK libraries for many different languages. If you're writing your CDK code in Python, you are limited to Python in your follow-up projects. So we decided TypeScript is the way to go for us. Of course, you can write Node.js Lambda functions. That's a plus for us as well. It's one of the fastest runtimes you can choose from with AWS, so another good point towards TypeScript. And of course, if you connect everything with a modern front end, you have the big three, Angular, React, and Vue, and they are all tailored for TypeScript development. So one thing in advance, we document our software development with architectural decision records. Maybe you have heard of this. It's not a real standard, but it's gaining widespread adoption, and it's a lightweight way to document functional and non-functional requirements. And you get tooling for it via NPM to help you manage that. And on the right side, I put in the decision to use architectural decision records. And of course, they get committed to your repository. So let's talk about the CDK. CDK is great, and I like to use it every day. As you might know, it's based on CloudFormation, and there are certain limitations for CloudFormation. The most important one, for us at least in this talk, is the 500 resources per stack. So if you're building a CloudFormation template and have a stack in it, it can only have up to 500 resources. If you go over this limit, it won't deploy. So this number might seem big, but it's not, trust me. And if you have a larger scale CDK app, you will reach this number very quickly. So what's the solution for this? You can always use nested stacks. Nested stacks basically are stacks on their own. They get their own template, and you can nest them inside of stacks. And you can even nest them inside of nested stacks. So you can build up your whole application with nested stacks and not reach the 500 resources limit. Okay. Now we come to code organization. How you organize your software code when developing a large app. Structure is everything. Okay, this example, of course, it's only one example. There are many different ways to develop these kinds of things. And in this example, we're using a monorepo, and we manage it with Learner. Learner is a tool which helps you delegate commands to all the different packages inside of your monorepo. And it even helps you version those packages. On the right side, there is a typical structure of the example project. And as you can see, we have the packages folder highlighted. That's where by default, the packages for Learner are located. And backend and frontend are complete projects on their own with package.json and whatever you have. So, but how you decide how to create packages? So there are three ways, in my opinion. You can do that. You can do it by technology. As you can see on the right, I have a constructs folder inside of the repository. And this is where I chose to locate my constructs. So it's technology based. That's JSII constructs. And of course, you can always choose to structure by business logic. And this is what we don't have here, because it's a structure of a larger scale app, but of course the demo application is not that large. And of course you have by functionality, and as you can see, the backend and the front end package. So backend functionality separated from the front end. The next thing you have to take care about is what package manager you want to use. Of course, Node.js comes with NPM. That's the default. But in our case, we are using Yarn, and especially for one feature of it, that's the workspaces feature. And the workspaces feature allows you to hoist all the dependencies of all your packages to the root folder, to the root node modules folder, which is marked here. And at the bottom, you see the equivalent of the package log.json from npm. It's the yarn log. So another thing we like to do, and which I find is very, very handy, is using conventional commits. There's a specification online. You can take a look at it later. Basically, it states that you have to format your Git commit messages a certain way so that in the end, you can generate, for example, a changelog file from it and have nice readable commits. There are different plugins which can help you enforce those specifications, like commit.lint, and Commitison helps you even formulate it. So here you can see my history, Git history from our example project, our demo project. You see it's not that big, but we have a few commits, and you can already see that they are formatted a certain way. We have the feature, and in brackets you have the module which the commit changed, and then you have a short explanation what happened. And as you can see, we have chore commits throughout this history where the CI/CD pipeline versioned the software. So you have this history, and if you use plugins like Learner can do, Learner can create a changelog for you. It will turn this Git history into this. It's a nicely readable markdown file. You can distribute, you can publish whatever you might want to do with it. Okay. Next thing I want to talk about is linting your code. So if you have a larger scale application with lots of source code files, static code analysis is really important. So which is also called linting. And if you know ESLint, it can help you find problems in your code and even fix them automatically. And of course, there's an NPM package for it, and it can help you do that automatically. So here's just an example of what the linting run on the example project looks like. As you can see, the colored entries, they are the different packages in the project. And Learner runs linting in parallel on every package and lints the JS, TypeScript, and Markdown files for us. And if everything is wrong, it would throw an error and you can fix it. After linting, it's always nice if you have a unified code format. So if you use something like Prettier, Prettier can format your source code with very few and simple rules, like having 2 spaces for a tab, or what line ending should look like. And you can configure that pretty easily with Prettier. And it's very well integrated into IDEs. And you can, of course, trigger Prettier automatically via your command line. And it can even fix automatically some of the formatting errors you make, like forgetting commas or semicolons at the end of lines. So, for example, the output of the format, the Prettier format, just like you saw with the ESLinting stuff, this is the output of the Prettier, and you can even see here which files are touched by Prettier and which are formatted by it. So I already talked a little bit about doing stuff automatically, but how you really do it. Since we have Git hooks, and you should really use Git hooks if you have a larger team and larger code base. So here, as an example, We use Husky. Husky is a very nice library which can manage your Git hooks inside of an NPM project. And for example, I have here the pre-push hook and the commit message hook. And as you can see, it's just bash scripts. And for the pre-push, in line 4, you see he just takes care that your working directory is clean, and then he just runs the tests. And if the hook comes out with an exit code of 1, so it failed, he won't push your code. So it won't get into CI/CD on the server. And on the right side, the commit message hook, it's just an example. If you have the conventional commits specification applied, commit lint will check if you adhered to the convention and will exit if you don't. Okay, so that's the structure and a little bit of tooling out of the way. So let's develop some stuff. So of course, you need, as with every CDK application, you need your main stack. So the stack that gets deployed to AWS in the end. So this is a standard CDK stack. Basically, you can create it via the tooling from the CDK, and then you start building nested stacks. And you instantiate, so you create the nested stacks inside of the main stack, you configure them, and of course, you gather outputs from the nested stacks. So you can imagine if one stack is dependent on another stack, then maybe you have a DynamoDB table created in one stack, and you need this table in the next nested stack. You can do that via the CDK by giving the DynamoDB resource as an input in the stack that needs it. But of course, you need to output it from the stack that creates it. And the rest is handled by the CDK, so the stacks get connected via inputs and outputs automatically for you. So this is the main stack of our example demo project. As you can see, it's not that big. It's 34 lines of code. If you're familiar with TypeScript, I think this is not magic for you. We're just instantiating something. The nested stacks, for example, in line 16, there is a deployment nested stack that gets instantiated, and the deployment stack has some attributes, bucket and distribution, and I take the bucket and the distribution domain name because I need that for my outputs later on. The bucket you can see in line 22. So there's the output, which just outputs the bucket name, which will be of importance later on. And of course, we need our CloudFront distribution name, so I put it out as well. So I mentioned JSII. So we create our nested stacks with the JSII compiler. It's also an AWS project, and it helps you write your stacks, your constructs. You don't need to write stacks. You can write simple little constructs in it, and then use it in many other languages. And the compatibility list is here on the right. So currently you have C#, Go, Java, JavaScript, Kotlin, Python, and TypeScript, of course. So your written construct in TypeScript gets compiled or transpiled or whatever you might call it to all those languages if you want. And since if you're working on bigger projects, the project will not be your last project, and maybe you want to do another project, and maybe that project will not be in TypeScript, but you still want to have a deployment stack in Go. So you can build that in TypeScript and publish it. The next thing we need to talk about is Lambda functions. If you do Lambda functions, at least in the tutorials I found on the internet, it's always just copy a JavaScript file in your CDK project and be done with it. And this, of course, won't scale. This cannot be tested really well. And so there's a solution for it. And this solution is called the Node.js function CDK construct. It's part of the API. You can use it, but I think not many people know of it. So if you use it, basically what happens technically in the background, your TypeScript Lambda, you can program it in TypeScript, of course, and the Lambda function gets transpiled via ESBuild down to JavaScript. It gets automatically packaged and production ready in a production ready format, and gets uploaded as an asset for your CDK application. There are a few conventions you can use with the Node.js function. The screenshot on the right shows you basically in the Lambda function TypeScript file, we create the Lambda function, the Node.js function, and it automatically searches for the Lambda function code by convention with the file name you see right above it. So the FizzBuzz check is the ID of the Lambda function I create in the Lambda function TypeScript file. So how does it look in code? As you can see here, this is the Lambda function. Basically, what I like to do is I always extend the CDK classes, because in the end, I can write a unit test for my personal FizzBuzz check function, and I can assure that some properties are set the way I want to. So basically, I just extend the Node.js function, and inside of the super call in line 8, I just configure the Node.js function. And you see, it's not much here. It's log retention, and I want it to be on Node.js 14 runtime. And the rest is by convention automatically taken care of for me. So this is the Lambda function. It's has nothing to do with CDK, of course. It's just a Lambda function in TypeScript with type information. And you see, it's nothing big, nothing fancy. It's just a little bit of getting an input number and deciding what to output. If the number is if you can divide the number by 3 and 5, you get FizzBuzz as the result. If you can only divide it by 3, you get Fizz. And if you can divide it by 5, you get Buzz. And if it's not divisible by any of 3 or 5, you get not matching. So that's our demo function. Okay, so what's missing? It's the front end. So we like to use Nuxt. Nuxt is a little add-on, I would say, for Vue.js. It helps you generate a nice and easy static front end from your mostly dynamic Vue.js project. So we like to use it. And of course, we need to connect our front end to our AWS backend. And AWS has a solution for this, and it's called Amplify. And Amplify is not only a toolkit or a service by AWS, it's also a library which you can use inside of your JavaScript code. So how does Amplify work? Basically, in your front-end application, you need to tell Amplify what you want to use from your backend. And in this case, in our demo, we have a REST API on the API gateway, and we want to use it, of course. So we read in line 24 the outputs JSON, and inside of the outputs JSON, there are the outputs of the stack, and inside of the outputs, there is the endpoint of our REST API. So we pass the outputs JSON, and as you can see in line 15, we configure our REST endpoint. So now we have connected everything, but of course there's more to a software project than just developing the source code itself. You need to have testing in place, and you can do your testing with Jest. Jest is a pretty simple and nice way of doing your unit testing with the CDK and for your Lambda functions and your front end as well. It's fast, it got code coverage built in, it got mocking built in, so it's very nice to use. So here you can see a simple CDK test written in Jest. So you have all the preparation stuff up until line 15, where the first test is taking place. And this test just takes a look at the generated cloud formation and searches for the Lambda function. And the rest of the call in line 16 is the properties of this Lambda function. And if the test finds a resource in the CloudFormation template that matches those properties I specify here, the test is successful. You can leave out properties, that's no problem. But of course, if you list one of the properties, for example, if the handler name is not index.handler, the test would fail. And as I said, you can write a test for your Lambda function, which is the same format, but of course it's different technology you're testing. So we're using the Lambda tester package here. And in line 8, we call the handler, which we wrote, and put in an event and try to verify that the result is okay. So this is just the first 13 lines of this test because it's very long. It tests all the different aspects of the Lambda, all the failure cases, and a lot more. Okay, so now you have your application, and of course you have your testing. Now it's time to fully automate your continuous integration and deployment. And the first thing you want to do when working as a team, you want to work with pull requests or merge requests in some services. So as you can see here, I'm using GitHub and GitHub Actions for the whole CI/CD stuff. And on the right, you see our integration workflow. The integration workflow basically is triggered when somebody creates a pull request. So you change something, you added a feature, you created a branch in Git, you pushed the branch to the remote, to GitHub, and then you create a pull request. So what a pull request allows you to make a code review. So one of your other team members can take a look at the code, can see if everything checks out, if there's something missing, and so on. And of course, you can run automated tests. Not only tests, but also static code analysis in this case. So as you can see on the right, we are checking out the code in line 9. We're setting up Node.js with our private package repository in line 13. Line 20 is install dependencies. Line 24 builds the sources. 26 lints the sources. 28 runs the test. And if that checks out successful, then the integration is at least mergeable. Then the code reviewer decides if that change is supposed to go into the main branch. The next step, if something gets merged to the main branch, of course, you need to create a release. And for us, or for me, a release is always bound to a certain version. So everything that gets merged to the main branch will trigger a new release, a new version on the source code. What that means is you put a new version number and an increment of the old version number in every package JSON you can find inside of your mono repo. Of course, it changes the source code, and that needs to be committed back to the repository, but that's the way it goes. Of course, the change logs generated. If you do a release, that's why we have the conventional commits in place. And after this was successful, of course, you want to deploy everything to AWS. And after you deployed successfully, you want to upload the outputs JSON which I can show you just in a minute, how this is generated to your S3 bucket where the front end is located, so that the front end can pass the data, the outputs, and initialize amplify. Okay, so here's the first part of the release workflow. It's split in two because it's a little bit longer. Basically, it does the same as the integration up to a certain point. So let's skip. This is just setting everything up, checking out the code, and setting up Node.js. And the second part is the interesting one. After you install the dependencies, build the source code for safety, just run lint and testing. You release the version in line 37. Luckily, Learner does it for you. So you just have to call a script inside of our package.json yarn release. It's calling Learner version, and then everything will get handled for you. So that's very nice. And of course, if that checks out, you need to upload everything. And for this, you need AWS credentials. As you can see, they come out of the secrets from your CI system. And this are the secrets in GitHub Actions. So you have the access key and the secret key and the region where you want to deploy to. And in the next step in line 45, you have the actual deployment. And as you can see, it's just a yarn call, a yarn workspace call, because the backend is one of the packages. So you need to tell yarn what package it is. And then you just run CDK deploy, require approval never. You don't want to have yes or no questions in an automated environment. And then the important part, the outputs file. So basically what it does, it takes all the CloudFormation outputs your stack produces and writes them to this JSON file. And after you have the JSON file generated, of course, you need to upload it. And I wrote a little shell script for it. So it uploads with the AWS SDK and uploads the JSON file to the front end bucket. Okay, so this is what the actual outputs file of our demo project looks like. And as I said, this outputs file configures amplify. As you can see, we have every output you may have noticed from the source code, the distribution domain name, that's where the frontend is located after deployment. And you have the frontend bucket name, which is needed for the upload, of course, the region, and the REST API endpoint. So everything I just showed you in little examples is located in a GitHub project. You can take a look at it either by searching it with the information provided at the bottom, or you just use the shortened URL to reach it. You can dig deep into everything. There's a lot that can be done in addition to what I have done for this project. For example, you can build ESLint configuration, prettier configuration in its own package and just reference it. You could do a lot more. If you're doing software development, you will know that you can always do more to make it better. So the front end is located under this URL. You can take a look live what it does. One note, I couldn't fix a course problem today. So if you are visiting this site, please deactivate course checks, at least for now, for this site, so that everything works as intended. I will fix that in the next couple of days, and then you can use it normally. So this is what it looks like. If you go to this demo site, it's just a little front end, and what it does, you can see at the bottom, it just generates a random number, and then the number will automatically be sent to the REST API endpoint, as I mentioned earlier, you will get an answer if it's dividable by 3, 5, or both. And if you want to do it again, you have a link. If you click it, a new number is generated, sent to the backend, and you get another result. So, conclusion. You have seen that it's totally possible to build a fully automated software solution based on AWS and the AWS CDK, of course. But you need to leverage the right tools and libraries. And you can do it in a monorepo. You can do it in multiple repos. That's, of course, up to your choice. But I just showed you a way that you can do it in a monorepo with TypeScript and the right tools. So thank you very much for listening. I hope it was fast, of course. Lots of stuff to cover. I hope you can you can find time to dig into the source code on GitHub. It took a lot of time to build this. So if you have any questions, just let me know. You can find me on the listed addresses. Thank you very much.
Yeah, thanks.
That was a great talk, and it's good to see, I guess, the I guess a more real world project setup, more typically how you would set up a project of this type, like, having those structures in place, really, I think, especially if you're going down the monorepo path, having that well laid out will, because if you don't lay it out well, you end up with that being legacy and being painful to work with and makes everyone unhappy. So yeah. I think it's it's good to see that there was a lot of thought gone into, how to structure that and the pros and cons of different approaches in structuring that. I think that's really important to do. I think that was really good.
Trust me, there were many different projects that led up to this result, which were not so smooth in the beginning. But you are totally right. If you don't set it up correctly, monorepo will do you more harm than it will help you bringing the results to your customer. Yeah. But if you do it right, it really helps. It's you have a more speed in developing, faster time to production. It's very nice if it works.
Yeah, I really liked it too. So one question from me and then one question from the chat. Did you look into Progen to manage your repo? I know that Lerna is not supported yet, but
that's the reason why it's still the handcrafted way. I took a look at Progen. I'm not convinced yet to use it, but it's getting better and better every day. So maybe at one point in the future I will switch. Right now, it's more work to put all this configuration stuff together by hand, but you can leverage a unified ESLint config or Prettier config or whatever inside of its own package and just import it, reference it, and you will get along quite nicely. But yes, Progen is something for the future.
Yeah, perfect. And there's a question from the chat, which is, what are the main reasons to structure by tag instead of feature or something else?
Good question.
You're not restricted to one structure method. Of course, I wanted to have my polyglot libraries, my constructs for the deployment of the front end and the API. I wanted them separated from the front end app and the backend stack, which is not polyglot. So I structured it by technology, basically. So I put up a folder named constructs where my JSII constructs are located. But inside of this, I can easily structure again by functionality, by business logic. It's just a matter of taste.
Yeah, perfect. So another question, if you run this pipeline, do you still build, run, compile, synthesize everything? Or do you have some way to have some intelligent building, like, okay, only this part changed, so I'm only building this, or is it still the same, this is one CDK app, I'm building everything?
Yeah, in the end, in the pipeline, he builds everything. because it's very hard to detect what changed and whatnot. So the amount of time you would put in to develop a mechanism to detect that outweighs the benefit you get from it. Build time is the only benefit you get. It's pretty fast. If you ask me, of course, we have projects that need half an hour to deploy, but that's not the compile fault, it's the deploy fault. CloudFront sometimes takes 10 minutes to deploy if it wants to distribute something. So compiling, linting, testing, it's always a matter of seconds, and the deployment part outweighs everything. So before you take time and optimize the building time, deployment time is much more important.
Yeah, totally. If you have CloudFront, you don't care about build times. But it's better. It was 40 to 50 minutes. Now it's 5 to 10. So
yeah. But as you mentioned it, we use lint staged. I don't know if you know it. So if you commit your source code, he will only do the checks for linting and unit testing for the code that changed. So if he detects that you only changed the Lambda code, he will only use the unit tests for the Lambda. And this helps you when developing locally, so that you have a faster development cycle.
I think especially the other way around. So I have serverless projects that have like 40 or 60 Lambda functions, and I change something. I don't want to run all unit tests against all the Lambda functions because nothing changed in the Lambda function. I changed maybe some coarse stuff because it's always coarse if it's front end.
Yeah, right.
It's like DNS in the back end.
But of course, if it comes to the CI/CD server, then everything gets tested again. But that's not of your concern because it does not happen on your computer. So you're fine and can go on with your development.
Yeah. So
I had a question. You mentioned like the use of conventional commits, and like that is obviously pretty topical. Seems to be very topical right now. Have you your experience in kind of using that in real projects? Have you found ways to then take advantage of the fact that that's being followed and that's being enforced in automation and in other things as well? I noticed in the build, you're skipping the tests if they had skipped CI in the commit message and things like that.
Right. Yeah. For now, the only benefit you get is that you have a nice changelog. Even your project manager, which is not technically involved in programming, can read those changelogs and have an idea what the commits mean. Because sometimes developers come up with really strange commit messages, and with conventional commits, you have at least some notes that what it is. Is it a feature? Is it a fix? Is it just fixing some tests? And of course, in the monorepo, it's important where this change took place. So you have this module name that you must specify. So if a commit starts with feature backend or feature API, okay, this seems to be something dedicated for the API package, and that helps a little. But outside of the development phase, the changelog is still pretty technical, of course. You won't take it and upload it to Jira, for example, or send it out via email to some stakeholders. It's pretty technical. But for the development, I think it helps.
And it's basically the default that Progen, CDK, and all these underlying tools also use. Yeah.
Cool.
So, and there's one more question, but I think it's more a misunderstanding, but maybe you could clear it up. So what the advantages are of using CFN outputs instead of using class fields. If you could go back to the slide in the shortage of time, I think it's mainly a confusion because of the destructured way of writing your code. There are two separate concerns. One is giving outputs to other stacks, and one is giving it out to the front end, and this is the difference, I think. But maybe we can show it again and you can elaborate some seconds on it.
Okay, I need to share it again. Sorry. Share screen. And there it is. Okay, so,
so the question was why using CFN outputs and not passing objects to other stacks?
Yeah, this is the main stack. So there is no other stack around this one. So at least at this point, you need to use the CFN, the CloudFormation outputs, if you want to have something to be known to the outside. The outside is, of course, the CloudFormation service or the outputs JSON. So you need to create these outputs. If you, maybe as an example, in line 14 from the deployment stack, I take out the bucket. The bucket is just a field inside of the deployment stack, a class field. And it gets filled with the CDK resource for this bucket. And I take this from the deployment stack here in line 14 and use it in line 23 to get the bucket name. Of course, I could easily put it into another nested stack as an input, and then CloudFormation would generate the input-output stuff for me. But that only works between nested stacks. And this is the main stack.
So within the same stage. So I think the thing is really, it's not multiple stacks that use these shared assets, but it's putting it to the front, because it's always the same with front ends. It's a chicken and egg thing. So you need the bucket to upload it, and it's not within the same synthesis state.
Yeah.
Thanks for this.
Go
on.
We don't have resources here that are needed in the other stack. So this example is not very good for this type of situation. So,
okay, yeah, perfect. Thanks. So I will move you out of the stream and welcome the next speaker. So welcome to the stage, Michael. You are going to talk about serverless authentication and authorization.
Hello.
We had this about the voice before, like authentication, authorization, and the German equivalents. It's always funny to see which is which. I hope your talk will help us with this. So, Aaron, any?
Yeah, as I said, looking forward to the continuation of this topic. I think it's super important, especially I think now in giving some concrete kind of examples.
Mm-hmm.
Yeah, so if you share your screen, I can put it up to the stream and we can just go ahead.
Yes, I will start sharing. Okay, does it work?
Yeah, it's there, so go ahead.
Okay, great. Thank you. Okay, then hello everyone. I would like to welcome you to our today's talk about serverless authentication and authorization at the AWS Community Day. In the next round about 40 minutes, I will talk about serverless authentication and authorization in the AWS cloud. Before we start, a few words about me and also some words about Entity Data, the company that I am working for. Okay, my name is Michael Loibl. I am working at Entity Data since 2017. And since then, I was involved or I worked in enterprise AWS cloud native projects on the one hand as a software developer and architect, and on the other hand as a cloud native infrastructure and operations developer, especially but not only in containerized cloud native microservice landscapes, you can say. And if you have any topics or questions, please feel free to write me an email that you see here, or you can also contact me, for example, on LinkedIn. The address you can also see here. Okay, so much about me. As mentioned before, I'm working for Entity Data. Entity Data is a Japanese parent company of the Entity Group. At Entity Data, we have subsidiaries in almost 90 countries worldwide, and our services of Entity Data are modern application development, especially, but not only, within the cloud area. But Entity Data also offers other services like IT consulting, requirements engineering, and also, for example, cybersecurity is an important service that we offer. Furthermore, Entity Data has a lot of partnerships, you can say, with different, for example, cloud providers, So for example, we are AWS Advanced partner since around about 1 year, I think. Okay, these were a few words about me and entity data. Now let's start with the actual presentation about serverless authentication and authorization. Before we start, let's have a short look into today's agenda. The talk today is divided up into 4 parts. Firstly, I will give you an introduction into the use case that we have implemented. Secondly, I will talk about the AWS services and technologies that we used within this use case. Then finally, I will explain you our real implementation. And finally, I will give you a small live demo where we test the secured backend that we implemented to show you the authorization mechanism in a small live demo. Okay, then let's firstly talk about the use case within that we have implemented an AWS serverless authentication and authorization solution. We implemented the solution for one of our customers within the automotive industry. In general, you can say the scope of this project was a central backend platform that managed vehicle data centrally and exposed REST interfaces and services to fetch, for example, vehicle data, calculate vehicle prices, execute vehicle constructability checks for a given vehicle configuration, and things like that. And now, the important service within this project is the so-called vehicle management UI. Within this UI, it should be possible that some administrators can centrally configure information for vehicles and only authenticated market administrators can configure market-specific vehicles. That mean only market admins that are allowed for a specific vehicle and a specific country can update their corresponding vehicles and vehicle settings. We see it here in the following example on the right side. We see here a user, for example, in this case, Max Mustermann. And in general, the market admin Max Mustermann is allowed to only configure cars for their country, Austria. So AT means Austria here. And firstly, there was the need to implement and log in with an identity provider like Google. So we see it here. And after the login, Max Mustermann is then within the mentioned vehicle management UI. And here, firstly, this market administrator firstly selects a vehicle group, for example, a car, and select an associated country like Austria, and then he can search cars in Austria. And this should only work if Max Mustermann is allowed for cars in Austria. In this case, this is okay. And then he sees all cars in Austria and can select and edit for the whole country vehicle-specific settings. For example, if we select motorcycle for Germany, this should not work. And for this scenario, we implemented a serverless cloud-native authentication and authorization solution. Okay, and these were a few words about the general use case that required, as mentioned, authentication and authorization. For the implementation of this authentication and authorization, we have used various AWS services and technologies. Before we look, you can say, in the real implementation that we did, I want to introduce you now these services and technologies that we have used. And then if we have a better understanding, I will give you a deep dive introduction about our solution that we have implemented. Firstly, let's talk about the AWS API gateway. The vehicle management UI communicates with a RESTful backend, and the associated REST services or REST endpoints are exposed with the AWS API gateway. Therefore, let's firstly talk about the AWS API gateway. So what is the AWS API gateway? An API gateway in general is the central access point for all requests to the backend services, or in other words, the central access point into your microservice world, you can say. At this central point, you can control access rights and implement security, transform request and response bodies, cache data, enable and manage stores, deploy multiple versions, and things like that. And AWS offers exactly such an API gateway with the service AWS API Gateway. I think the most of you will already know this. And with the AWS API Gateway, you can create RESTful APIs, pure HTTP APIs, and it is also possible to deploy WebSocket APIs at any scale. The AWS API Gateway is completely serverless. That means there's no need to manage infrastructure like EC2 instances, take care about high availability, take care about scaling and things like that. And finally, you can say that the AWS API Gateway is very well integrated with other services. So it is very easy to forward requests to backend services like, for example, AWS Lambda, or forward traffic to a private VPC and there to an elastic load balancer, for example. Okay, and these were some general words about the AWS API Gateway. Let's now take a closer look at the security area, you can say, within the AWS API Gateway. So as mentioned before, AWS offers different ways how you can secure your API. In general, you can say the AWS API Gateway offers 4 possibilities, or more or less 4 possibilities, how you can secure your APIs. Let's now have a closer look into them. Firstly, I will talk about a security mechanism with so-called resource policies. With resource policies, you can allow or deny access to your deployed APIs only from specific whitelisted IP ranges or VPC endpoints, for example. In general, you can say this mechanism is useful, for example, if you want to configure network access for the API gateway. Let's say, for example, if you deploy your API gateway completely in a private way and you need to enable access only from an VPC endpoint from another VPC or another account from, for example. Or another example, if you need to enable access only from certain IP address ranges, then you can configure this also with so-called resource policies. Okay, another important security mechanism for the AWS API Gateway is security with AIM roles and policies. In AWS, and this is the important point with this mechanism, in AWS, every single REST endpoint has its own AWS ARN, so it means its own resource number. And this gives you, therefore, the possibility to secure every endpoint with an AIM role and associated policies. The policy contains then, for example, an allow action to the specific resource ARN. So, for example, let us imagine you have an endpoint called /users/ID. So get the user by ID, so /user/ID. Then this specific endpoint has its completely own ARN, so its own resource number. And this resource number can be then used in a policy where you can give an allow permission to the action invoke API for this specific resource ARN. That means you can use the whole power of AIM by configuring roles with associated policies at REST endpoint level, what is very, very powerful, you can say. And this is also the mechanism that we used in our serverless authentication and authorization implementation of the vehicle management UI that we will see later in more detail. Okay, another powerful access control mechanism you can use are so-called Lambda authorizers. On the level of the AWS API Gateway, you can configure so-called authorizers. Here you can configure an AWS Lambda function, you can say. This authorizer then, that means this Lambda function, can be then attached to every single REST endpoint that you have deployed within the API Gateway. So every incoming request then reaches an secured REST endpoint, and this request will be then firstly forwarded to the Lambda function. That means the Lambda function reaches an event with the content of the current request. And within the Lambda function, you can then implement any logic you need to handle the authentication mechanism. The Lambda function on the one hand can then return an allow result if everything was okay, or the Lambda function can return and deny if something went wrong during the authentication. In case of an allow, the request will be forwarded then to the backend behind the API gateway, and in the case of an deny, the request will be rejected and an unauthorized response is the result. So to sum it up, Lambda authorizers offers you also a very powerful authorization mechanism, because you are completely free about the logic that you will implement within this function, which offers you in the end the maximum flexibility you need for a powerful authorization implementation. And furthermore, your whole authentication flow is also completely serverless if you combine API gateway with Lambda authorizers. Okay, now let's finally talk about the fourth mechanism, Cognito user pools. I won't say too much about Cognito user pools, as this service was not directly used in our serverless authentication and authorization solution, and therefore I will keep this short. But in general, you can say a user pool is a user directory in Cognito, and with the user pool, users can sign in to your web or mobile applications through Cognito, as they can do it with other identity providers like, for example, Google or Facebook or something like that. And after successful authenticating a user, Cognito issues a JSON web token that you can use to secure and authorize access to your own APIs. And within AWS API Gateway, you can create an authorizer, okay, as you did it with the Lambda authorizer, but here you select Cognito as an authorizer or as the authorizer. And if you call your API, then you will call it with the JSON web token, okay, that was issued before by Cognito, and the API gateway automatically validates the token with Cognito in the background. This is fully managed by AWS. Okay, these were some words about Cognito user pools. And in general, this was an overall introduction to the different possibilities of securing AWS API gateways. We are now focusing especially to the possibility of AIM roles and policies, and I will show you in a more detailed way how this mechanism works, because as mentioned, we use this mechanism in our solution. Okay, in general, you can say that API gateways that are secured by AIM are called with AIM credentials. As you probably know, you can create so-called AIM credentials for a specific role, which consists of access key, secret access key, and session token. So these keys are the programmatically representation, you can say, of a role with their associated policies. And these credentials must be used. We see it here in this architecture on the first step. These credentials must be used if you send requests to an API endpoint that is secured by AWS AIM. So let's imagine we have an endpoint. For example, we see it here, an endpoint API v1 with this own endpoint specific IRN. So this endpoint has, as mentioned before, his endpoint specific AWS resource number. And then there's also a role with a policy that contains an allow for the API invoke action to this specific endpoint ARN. And then you create AIM credentials for this role and policy, and these credentials then can be sent to the API gateway in a signed form. The API gateway validates the signature of the credentials and validates then the credentials against AIM. And if the validation is successful, the request will be forwarded to the backend. And if this validation was not successful, for example, if the policy behind the AIM credential does not have an allow permission for this specific endpoint, then the request will be rejected on the API gateway level and an unauthorized response is the result. Okay, this was an overall introduction into the AWS API gateway and especially how you can implement different security variants or mechanisms into it. Now let's talk about another service that we used in our implementation and that I would like to present you, AWS STS, what stands for Security Token Service. Let's talk about what is AWS STS. STS is a service that enables you to create temporary limited privileged credentials for an AIM role with its associated policies. STS is a global service that can be called with all known AWS mechanisms. That means STS can be called with the pure HTTP API. You can call it also with AWS CLI or with an appropriate SDK with the programming language of your choice. And you can call STS to create temporary credentials with different so-called STS actions. So there are different actions available like STS assume role or STS assume role with web identity or STS assume role with SAML and further actions. And we see here an example of an STS call for the assume role action. And simple assume role means that the temporary credentials are created for a specific AIM role that you can specify within the STS call. So we see it here in the step 1. An STS request is executed here against the HTTP API for the action assume role. So we see it here. We execute the request against the pure HTTP API for the action assume role, and we want to assume this role. And we see this role here also in AIM. And yeah, we want therefore create temporary credentials for this role that is valid for 300 seconds. And yeah, afterwards, the request reaches then STS, and STS communicates internally with AIM to assume this role that you specified within the request that I showed you. And STS generates then the temporary credentials for this role, and the result are the access key, secret key, and session token. In this example, the role contains a policy that contains permission to access, in this case, DynamoDB. And with this temporary credentials, you can then call, for example, DynamoDB with this limited credentials, because we see here the policy of this role contains, in this example, full access to DynamoDB, and the temporary credentials are generated for this policy. And these temporary credentials can then use, for example, to talk with DynamoDB. You can use, for example, this if you work on a feature branch, for example, on your local host, and you want to connect to the dev environment to write and read things to a real DynamoDB in a dev environment, but you're fully working on your local host, for example. And the advantage is you do not need long-term persistent credentials on the client for this DynamoDB call. You only get temporary AIM credentials that have limited validity, for example, 50 minutes, and that's it. Okay. These were some words about STS, and let us finally talk about another technology or protocol that we used in our serverless authentication and authorization solution, OAuth and OpenID Connect. This part is just a small recap, and I will not go so much deep here. I will only say a few words about it to provide a rough overview and bring the topic back to mind. Okay, only as a recap, OAuth stands for Open Authorization, and the OAuth 2 authorization protocol enables a third party application, you can say, to obtain limited access to an HTTP service. So that means third-party web services can access external resources without, and this is the important point, without disclosing usernames and passwords. In OAuth, there are different roles or actors like the resource owner, the resource server, and specific client, and in the end, the authorization server. In other words, you can say OAuth allows a user, so a resource owner, to access other web resources, what is the resource server in this case, using their own federated identity. And OAuth providers are offered by many services like, for example, Google or Facebook or Amazon and things like that. And often large enterprise companies have also their own internal OAuth provider. Furthermore, there are some so-called OAuth flows, like, for example, the authorization grant flow that we see here as on a high-level perspective in the example here on the right side. Let us now quickly go to this authentication processor flow, as mentioned on the example of the authorization grant flow. So we see here the user. Let's imagine, or if we take the example from the beginning, our market administrator, Max Mustermann, we see it here. And Max Mustermann wants to log in to in our case, to an web UI, but this can be also a smartphone app and things like that. In our case, this is this vehicle management UI. And the vehicle management UI then calls for the initial login, in our case, Google, for example, and Google redirects, you can say, the login screen from Google. Then the user, Max Mustermann, can enter his credentials for Google, so his username and password. And then afterwards, he send it back to Google. And Google then firstly send back a so-called grant code. This can be also done with a client secret and client ID and so on, but let us talk about grant code. And this step is you can say, temporary validation or security mechanism. And then the client sends the grant code back. And if this was successful, the result is an access token. And with this access token, our vehicle management UI can then access the resource server, in our case, the API gateway. And then the resource server can then validate the access token back with Google. And if Google say, hey, yes, this access token comes from me, it is valid, and so on, then the request can be forwarded to the backend. Okay, and then the question now is, what is OpenID Connect? OpenID Connect is an additional layer on top of OAuth, and OpenID Connect allows clients to verify the identity of the end user with a so-called ID token. Okay, what is a JSON Web Token? And the JSON Web Token contains different so-called claims like email, first name, username, or first name, last name, email, and a lot of other things. And therefore, OpenID allows clients to verify the identity of the user because this information are within the JSON Web Token. So we see it here. If you use OpenID Connect on top of OAuth, you have here the access token and also a so-called ID token, which is, as mentioned, a JSON Web Token that contains different claims that verify, or that you can use to verify the identity of the user in the end. Okay, these were some few words about, or quick recap about OAuth and OpenID Connect. And yeah, this was a general introduction into the AWS services and general technologies that we used for our serverless authentication and authorization implementation. So we talked about AWS API Gateway, we talked about STS, and I gave you a general recap of the OAuth protocol and OpenID Connect. And all these services are used within our implementation. And now I will explain you step by step the technical background. So as we did it for our sample implementation for this vehicle management UI. Only as a small recap, for the vehicle management UI, there must be an authorization way to make it possible that only allowed market administrators can access vehicle data. For that, they are allowed, as we saw it at the beginning of the presentation, where I explained you the general use case, but only as a small recap. Okay, now let's start with the technical details of our implementation. We see it here. For our solution, we used the AWS API gateway. We used AWS AIM. We used the Lambda function with the AWS NoSQL database DynamoDB, and we used STS. And firstly, if you remember the UI that I showed you at the beginning, the user will be logged in with an identity provider with OAuth and OpenID Connect. And therefore, we used here an example, as an example, Google, in this case, as the authentication provider. So the front end implement the authorization grant flow, as I showed you before in the section as we talked about OpenID Connect. So the user log in into the application with a Google login, and in the end, the front end contains a valid OpenID Connect token, OpenID Connect ID token, without this JSON Web Token that we see here. So firstly, the web UI executes the whole OAuth or OpenID Connect flow, and the result in the end, if everything was okay, is this ID token. And we see here the AWS API gateway. We see here two REST services. One REST service, we saw this at the use case description at the beginning, is this endpoint where you can fetch for a specific vehicle group, like for example, a car or a motorcycle, and for an associated country like Germany or Austria, you can fetch vehicle information. And this is secured by AIM. And the second endpoint is an authentication endpoint that we used now firstly, and to that the client sent this ID token. Firstly, we see it here. Afterwards, this REST endpoint is configured or forwards the request to a Lambda function that is behind this API. So we see it here, the request will be forwarded to the authorizer Lambda. That means the ID token also reaches the authorizer Lambda. And now the authorizer Lambda firstly validates the ID token against Google. And if Google says, hey, this is okay, then Google sends back an okay to the Lambda. So this is the flow that we saw before, where I explained you OpenID Connect, where the resource server in the end must validate the access token, or in this case, the ID token. And this is done here by the Lambda function. If this step was successful, the Lambda function extracts the user information from the JSON Web Token. Because as mentioned, this ID token that comes initially from Google is a JSON Web Token. That means this JSON Web Token includes user informations in a JSON format. And based on this user information, the user is then loaded from the DynamoDB database. We see it here. The Lambda function communicates with an DynamoDB database, and this DynamoDB database contains a lot of entries for every user with the associated permissions. So in this case, we see here Max Mustermann, and Max Mustermann can only access vehicle groups for car and for countries Germany. And this user information are then loaded by the Lambda function. And afterwards, if the Lambda function fetched this user-specific information, now it comes the most important or tricky part, or the most powerful part of this Lambda function, because now the Lambda function knows all REST endpoints that should be secured. There is an implementation within the Lambda function that automatically scans all available deployed REST endpoints. So at the end, that means the Lambda knows all REST endpoint ARNs that should be secured. We see it here. The Lambda function, for example, knows exactly this endpoint because, as I mentioned before, this endpoint should be secured, and therefore it knows this endpoint-specific ARN. And now the important point is that the Lambda generates dynamically a policy for this ARN, and the Lambda replaces this generic placeholders, because you can enter here any group and any countries, but the Lambda replaces this placeholders within this ARN with the specific permissions for this specific user, in this case, Max Mustermann. And the result of the policy that the Lambda generate internally is then, in the end, this ARN. That means this generic placeholders, because you can enter here, in the end, any vehicle group and any country, but the Lambda replaces these two placeholders with the real values or with the real permissions for this specific user, in this case, Max Mustermann. In the end, the resource ARN looks like that. It contains only an allow action for an execute API invoke for this resource ARN that contains a car and a country, Germany, for example. And now if the Lambda generates this policy dynamically, the Lambda now executes an STS call with, in this case, the Java SDK. And here we use the specific action assume role with web identity. And here we say we want to assume, or we want to create temporary credentials for this role. I will talk about in a few seconds about this role. And we enter here this dynamically created policy that we created in the step before, with this ARN that only contains car and Germany, because these are the permissions for Max Mustermann. And then the Lambda function sent this request to STS. And now the important point is here, with this STS action, assume role with web identity, then that now this is a specific STS action, you can say, because STS now generates temporary credentials for this role, this dynamic auth role. And this role, and this is the important point here, has a trust relationship to, in this case, Google. That means only callers that are trusted by Google, that means that they are authenticated by Google, can assume this role. And that means this request by STS in the background, this is done by AWS, this trust relationship check is done by the ID token that you entered here during the STS request. That means, or also a big advantage here is that the Lambda has absolutely no permissions to call STS. For this assume role with web identity, that this is not required. You send for the authentication, you can say, the ID token. And then the role that you would like to assume has a trust relationship only for Google authenticated users. And then with the usage of the ID token, the trust relationship is checked. And if this was successful, and this is successful in this case, STS generates then temporary credentials. So an access key and secret access key and session token. And afterwards, STS sent these credentials back to the Lambda. And in the end, the Lambda returns this generated credentials back to the client. And for a small recap, you see here, these temporary credentials at the end of the whole flow are generated for this policy, that means for this ARN, and that means for this specific REST endpoint car, so vehicle groups car for the country Germany. And now the client can use these credentials. So for example, if you have an Angular frontend, for example, you can use the HTTP client and you can send then these credentials in a signed form if you execute requests against the REST endpoint that is secured by AIM. And requests only works if the groups, in this case for Max Mustermann, only for cars and for Germany. Okay, this was a theoretical explanation, and now finally I will give you a very small live demo with Postman in this case. So firstly, let me generate quickly an ID token that then I can show you this in a real example. So we see here this REST endpoint. This is an old one. I enter here a new ID token. So we see here this REST endpoint. And now I will execute a request against this REST endpoint. And then in the end, this whole flow that I explained you will be executed. So let's go back to Postman and send the request. And now in the background, this whole flow that I explained you will be executed. And then in the end, hopefully, the result are the access keys that we see here. But I use no UI here. I use only Postman for this small demo. And in the end, we should saw now this access keys. And yes, the request was successful. And now we have in the response this temporary credentials. And now let's call the secured endpoint. So this one. Now let's fetch vehicles for car and for Germany, because Max Mustermann is allowed for car and for Germany. Now let's enter the access key here. Now let's enter here the secret access key. Now finally enter the session token. Okay. Session token. And as mentioned, for car and for Germany, and this should be worked because as we saw, Max Mustermann is allowed for Germany and for car. Send this. And yes, it works. The response are only cars with the country Germany, as we see here. Now, let's try, for example, motorcycle, okay, as an example for the country, let's say Austria, and this should not work. Test it. And yep, we see it here. Blah, 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 user is not authorized to perform execute API invoke on this resource motorcycle and for Austria. Test it again for car in Germany. Zack, this work. Okay, okay, that's it. This was a general presentation on how you can secure RESTful backends with the AWS API Gateway and other services and technologies. Thank you for your attention. I hope the presentation was exciting and you enjoyed it. If you have any questions, we can do it now in the Q&A session, or otherwise, hopefully, we will meet or hear from each other soon at upcoming conferences or meetups. And finally, some additional information. We are also hiring, so we are searching for cloud-native software developers and architects, as well as cloud-native infrastructure engineers. So if you're interested, search for us for entity data in the internet, and we are looking forward to hearing from you. Also, thank you to the organization team that gives us the chance to participate here today with our talk and presentation. Thank you and have a nice evening. And I give the word back to you, Thorsten.
Yeah, thanks. And I will directly forward it to Aaron. So
I think I wish I had that this talk in as a reference maybe about 6 months ago, trying to explain the whole IAM authorization flow. You did a way better job than I would have done. So I think that's I would have been great just to be able to say, here, watch this video, and then we can have a conversation, because it is one of those ones where it's not easy, and it's also not very well documented. So it's really great to have resources like now this talk, which we'll be able to reference in future. I think to be able to do that, because it's one of those ones that it does kind of, it's logical once you understand it, but you kind of have to walk through exactly the steps that you walk through in the presentation for it to kind of sink in, to say, especially the flexibility around dynamic policies, right? That is a really powerful tool, but super complicated. And the documentation, AWS documentation on it isn't that great. So it's great to have talks like this to kind of help demystify that.
yeah, thanks. I can fully agree. So most people are aware that, yeah, you can use API keys, you can use normal username, password stuff. But when it comes to tokens and all these dynamic credentials, this is really something few people know. And if you look at the documentation or any samples, it's, yeah, use an IAM permission with everything and it works. But that's not how least privilege works. So thanks for this really great talk about understanding this more in depth. And yeah, happy to have you.
Thank you very much.
So you already said you're hiring. I will take this chance to, again, put our sponsors on the slide. You are one of them. So we have so fantastic sponsors that are making this event possible. So thanks again to all of them. So I will remove you from the stream now, and we will go on with our next talk. Our next talk will be pre-recorded, but we will have the speaker on stage later on for the Q&A. But before, as I mentioned, we have great sponsors, and we have one main sponsor, and I want to show their video again. So let's directly jump into the next video.
Hello everyone, and welcome to the session where we will be making sense of data with the help of OpenSearch and its Node.js client. I bet each and every one of you deal with data in one or other way. Data is at the core of applications we build, whether it is the content of a website, the logs, geospatial information, or large, complex, unstructured data sets. In the modern world, data is everywhere. And for the success of our products, we need to deal with it quickly and efficiently with the tools we can trust. And luckily, OpenSearch checks all these boxes. Launched earlier this year as a fork of Elasticsearch and Kibana, the OpenSearch project has its own life now and is being actively developed by the community. It is a secure, high-quality search and analytics suite. And at the same time, it is a community-driven product which you can use, modify, and extend the way you need. That's why today is a perfect opportunity to learn how you can apply the power of OpenSearch to your projects. My name is Olena. I am a developer advocate at Ivan, where we do our best to support open source communities. I am also a software engineer and have been working with Node.js for a very long time. And I think OpenSearch and Node.js are made for each other. Stay at the session and you will learn how OpenSearch works, how to use its Node.js client. We will look at the building blocks of a request and demonstrate how to search, aggregate, and visualize the data. And before we jump into the code, let's align on the terminology we'll be using. So what is OpenSearch? Is it a data store or is it a search engine? It is actually both. The power and intelligence of the OpenSearch engine comes from how it analyzes data way before we start searching. The structure or the schema is called mapping, and the process of injecting and processing the data is indexing. During the indexing, OpenSearch creates documents for data items, analyzing the content and giving it bigger meaning than just a string of characters. This is where the text fields, are structured into a format optimized for search processing, taking into account numerous things. The resulting documents are stored then in one or more shards. Splitting the data across shards allows horizontal scaling, which we as engineers like so much, and an index is a logical grouping of shards. Next to the shards, we keep the replicas. These are copies of shards to ensure redundancy and resilience. Shards and its replicas are balanced across nodes, providing scalability and high availability. This means that if any of the nodes go down, we won't lose data. The group of nodes is called a cluster. OpenSearch knows well how to balance and manage multi-node clusters, so you won't need to do it manually. And now the question you might have is, how do we communicate with the OpenSearch cluster? The communication happens mostly through the REST API. OpenSearch provides JSON-based REST API over HTTP. You can send a request with curl or any other programming language. In JavaScript, we can rely on the Fetch API. This, of course, means that you would need to perform all these rudimentary tasks to handle the requests. That's why a more convenient way is to use one of the official OpenSearch clients. With their help, we can use a wider range of methods to communicate with the cluster, and the clients will do all the underlying REST API work in a secure and stable way. And this is basically the summary in under 3 minutes of how OpenSearch works. Now that you're proficient at the theoretical part, let's move on to the practical one. And I would like to encourage you to go along. To make things easier, I've prepared a GitHub repo with the code examples so that you can experiment with the search queries as well. Naturally, we will also need an OpenSearch cluster itself. Where can you get it? For the brave of you, you can set it up manually. OpenSearch.org offers guidance on how to do this. But for those of us who want to save some time, sweat and tears, we can use a fully managed suite. Ivan or obviously AWS are good choices. I'll be using Ivan for OpenSearch, and we will host the data in AWS Cloud. I already have the service up and running, so it's all ready. And lastly, of course, we will need some data for our playground. So I thought, what can unite countries of the DACH region? And I believe nothing can do it better than food. So yeah, today you and I, we become culinary chiefs and nutrition specialists in disguise, inspecting a variety of recipes. We'll be using dataset from Kaggle. You can find link in the repository, which offers 20k recipes with ratings and nutrition data. You can find it over here and download the JSON file, unzip it and put directly into the project. So with the help of OpenSearch, we'll look for awesome or awful things depending on your perspective, which people do with their food. So let me show you. I already have the files, JSON file in the project. Now, if you look inside the project package JSON, you'll see that we have a pretty minimalistic setup. We have the official Node.js client for OpenSearch installed, and we will use it for easy communication with the cluster. We also have .env to deal with the environment variables. I keep the connection string information in the .env file, and .env does the care of the rest. You can copy the .env example, replace the string with your service URI, and save it as .env. And this is just to avoid those awkward situations of committing the credentials into the repository. There are several other files where you can find different methods and showing different requests to the cluster. So for example, search, and you can see here that every method has a sample which you can run from the command line. We will see this in more details later. And to connect to the cluster, let's go to the config JSON, and over here you can see that we are creating new client object where we specify node property and setting it to the service URI which we just stored. This is a place where you can add some other information necessary for authentication, such as bearer token, SSL configuration, and everything else. In this file, I also set the index name, just that we use the same name everywhere and we are consistent. And also this is the file where we have a reference to the JSON object of recipes of the data which we will be using. Talking about the data, I think it is time to index or ingest it into the cluster. So go to the index.js file, and here you can find inject data method. We have 20k recipes, so it will take some time. How about I run this method and we will look in details what exactly we are doing here while it does its job. So it is possible to inject values either one by one, say if you have incoming logs, or by using a bulk operation. Because we have a file containing a long list of recipes, we are using a bulk operation. A bulk endpoint expects a request in the format of a list where the action and an optional document are followed one after another. To achieve this expected format, we use flatmap to create a list of such pairs. Great, the data is injected, and let's see, so errors false, so we didn't run into any issues. You might have noticed that here we didn't specify any schema for the data. And since we are experimenting, the easiest way is to rely on the dynamic mapping performed by OpenSearch. But are you curious to see what structure OpenSearch obtained from the data sets? Let's check it out. We will use the method which is called getMapping, and again this is part of the client and it is located in the indices namespace. So we just call this method and we say, okay, get the mapping, get the schema from the index with the name index name. So we can just copy this method and let's see. So here you can see the schema. So we have in our dataset such properties as calories, we have title, description, directions, list of ingredients, categories. You can see also that we have some types assigned based on how what OpenSearch analyzed from the data. So we have some keywords and fields. So this all we can use for our experiments. And now with this knowledge, I would like to show you an example of a search request. So let's go to the search.json file and let's search for something unusual and a bit ridiculous. Would you like to see if there are recipes for a soup with beer and garlic? Let's find out. And yes, we got some delicious and I would say totally unexpected suggestions in the response. The method which we run is quite simple. I actually use JavaScript properties over here, so the fields which we send in the request, such as title and the string, are the field and query which we expect as a part of the method. This is just to make it easier for you to experiment with the queries and put anything else you would like to see. And we are relying on search method provided by the client. And then we have a callback to log the information we received. So this looks pretty simple, but it's kind of a lot of properties and a lot of brackets. And actually, if you would look at other examples, the structure sometimes looks very similar, but with a bit of slight differences. It might get confusing very fast. But don't worry, it's actually not that complex. And what we need is just a lesson on the anatomy. Of course, not the corgi's anatomy, but the one of the request. And we will start with a search queries. The list of parameters which can go into the search request is long, but for a simple request we just need two. First is the index or a list of indices where to search for results. In our case, we search in recipes index. Second is the search definition inside the body property. Body expects an object based on JSON written in a domain-specific language. And within that, we have query object where we define type of query, and we right now run an example with match. We will see other examples soon. Then we need to define which field we are using for search. This is title. And then we define the text query itself. And if we look closer at the results, we can see that the first returned item is closest to what we searched for. So it has all three keywords. The second returned result only for two ingredients which we wanted, beer, crackers with garlic, and the rest have only beer inside of it. So this means that the results were sorted by relevance. You can also notice that the order of the words didn't restrict what results we received. And even though we requested plural soups with beer, we received a result where we had a singular word soup. So, but what if we cared about the word order? This is where match phrase comes in handy. Match phrase is very similar to match. So actually we just replace match with match phrase, and everything else, the properties stay the same. But match phrase also allows doing something really cool. It allows defining how far search words can be from each other to still be considered a match. By default, words have to be next to each other, but we can change this by defining a numeric property slope. I think the best way to understand it is just to try it out. So let's go to the next example. Let's use this pasta with cheese. And you can see that in the method I have here three properties: the field, the query, and the slope. So let's run it with no slope defined. We just have it like, look in the title for pasta with a cheese. And we got one solid suggestion. So we have some pasta with cheese and pepper. But what if instead of we will add slope equal to 5, let's see what we will have. So now we have way more results. We have pasta with feta cheese, pasta with goat cheese, pasta with burrata cheese, even some broccoli inside. Oh wait, not broccoli, it's cauliflower. So it makes us the search query way more flexible, or like it brings us more suggestions. And yeah, so this is how you can use slope. But let's move to the next example, and we will look at some desserts. So let's create a query where we will include and exclude certain words and write simple conditions, all in a single string. So here we don't have neither match phrase, we have a query string. And inside of it we have a query, and here you can see we have some pluses, minuses, or some other symbols. So here it means that we definitely want to have dessert or a cake within the results. We definitely don't want to have any garlic. Don't put garlic in our sweets. And then we have mango, caramel, or cinnamon. They are without neither pluses nor minuses, meaning they are optional components. However, their presence will increase the relevance of a search results. And another, or like some of the other properties which we can add, is actually to indicate which field should be used to search for this query. Yeah, so the query string syntax is a powerful tool which can be used for a variety of requests. It is especially convenient for curl requests since it is a very compact string. However, as the complexity of a request grows, it becomes more difficult to read and maintain these types of queries. In a minute, we will see how we can do it differently. But it makes sense to quickly show you another type of request first. A term level query. Unlike the queries we have seen so far, where we got results sorted by relevance and based on preprocessed text content, term level queries deal with exact matches for numbers, dates, or tags without additional analysis and without sorting results by relevance. For example, looking for recipes with sodium level equal to 0, or searching for a range between 0 and 100. And with this knowledge, we can now come back to the topic of including or excluding certain conditions. And to combine multiple conditions together, we can use Boolean queries. They support Boolean clauses such as must, filter, should, and must not. And in this example, I used a bit of everything. I think the best way is just to play with the code. If you look at other examples, so this is in the same file, you can find the query string, you can play with it, term, range, and Boolean, and just mix stuff. It's like a salad. You can add some things. Something makes it better, something makes it worse. Just try it out. Yeah, and I hope that I convinced you that using OpenSearch with the Node.js client makes it easy to search for data. However, that's not the only job of OpenSearch. In fact, many organizations won't even use the search. They will use aggregations. Aggregations, unlike search, give us an overall insight into the data. They provide metrics, statistics, and summaries. For example, What are the biggest traffic sources of users to your web application? What load time is of average and which one should raise your concern? Removing which files would bring the biggest difference when you run out of space on your device? And so on. There are a variety of aggregation requests. Their structure is similar to search queries, and they have, instead of queries, they have this UGs, and inside there is a name to label the aggregation. For example, we can call it metrics example. Within that, we specify which metric type to use, for example, average, but you can also look for minimum, maximum values or statistics overall. And then we can specify the field for which we want to collect the information. So let's quickly look at the aggregate file, and here let's run this method for getting information on the rating and finding the average value. And you can see it's 3.71. Not bad, I think. Apart from this, we can use aggregations to create histograms. And if you don't know what exactly histogram is, no worries. It is just a fancy word for frequency distribution. Although frequency distribution also sounds fancy. Anyway, histograms help us split data into buckets. For example, divide recipes into different buckets based on the rating. Or divide recipes into buckets based on the date when it was added to this dataset. Remember, we had the date property, so we have different types of date histogram which we can create. Let's actually go ahead and do it and see what we will receive as a result. So I'm trying the date histogram where the interval is a year and we are basing it on our date property. So let's get surprised. So we can see, if you go scroll to the top, that we can see the list of buckets, and every bucket has information on a year, particular year. So the interval, as you can see, 96, 97, 98, a year as we requested. And we can see number of documents which were which have this date as in that property. And for example, in 1996, we have only one document, and it's kind of small numbers till we get to 2004. Over here, 11,000 recipes were added to this data set. Interesting. Yeah, so, and you might be thinking that maybe we are a bit like tired looking at these numbers, especially after that beer soup with garlic. Can we see the data visualized finally? Great that you asked. We can visualize data and do so much more with the help of OpenSearch dashboards. Let me show you. So OpenSearch dashboards, let me go outside and go to home. This has quite intuitive interface, and we can visualize data and do so much more with its help. So for example, I have created a bar chart to see what is the median calories for different types of categories. And what kind of worried me is that the median calories, or like the highest median, is for the leftovers category. Yeah, it seems dangerous. Next graph which I tried is a pie chart. So here I decided to split the recipes into different buckets based on the level of sodium. And you can see that actually it's kind of balanced in a way. So depending on your preference, if you have any preference on the amount of sodium, you can find quite a lot of recipes in this data set. And the last one is a tag cloud. This is just to indicate which categories were used the most in the most frequent way. And for every of this graphs, for every of these visualizations, you can set a lot of properties to shape it the way you need to shape. Apart from that, that's where I think I showed first this page, is that we can go to DevTools and experiment running some queries from inside of OpenSearch dashboards. Maybe you would like to shape the query or try something more complex and kind of have a nice interface to deal with. Apart from that, if you go to home, you can add some sample data, and there are already some predefined data collections which you can try and explore and learn how to use and how to create a variety of charts. And this is actually what I wanted to share with you today. We went from connecting to the cluster to searching, aggregating, and visualizing. Thank you for staying with me and watching this session. I hope you learned something new today. Here is again the link to the Git repository. Play with the examples. Let me know what worked, what didn't, and what else you would like to learn. I will be happy to answer all your questions. Thank you very much for your time.
So we are back on stage. I hope everybody had a chance to lower the volume and not getting blasted right now without us talking. So I think we have 3 important questions that came up in the chat. One being, what is your obsession with beer and garlic?
That's a long story. I'm Ukrainian, so I would say garlic is part of my life. I'm also making sauerkraut at home. I think like the German cuisine is generally very close to the one from Ukraine. And we put garlic everywhere. I would say garlic and onion. Beer, I'm not really a big fan of beer, but I felt this is something which really unites our regions. So beer is always there.
So it's a bridge between the countries, is the beer and the garlic. Perfect.
Yes.
Yeah.
So the next question, being more on topic, if you have more examples on what OpenSearch can be used for. We saw aggregation, we saw search, but are there any other things that we could do with OpenSearch?
So many things. I feel OpenSearch can be used for spell checking, for auto-completion, for alerts, logs, metrics, as we have seen, for things with geolocations. I've been working with maps in the past, and I think it's pretty cool. So, for example, looking for using the rectangulars or polygons and searching for geopoints. Do they belong there or not? Specifying a distance and looking for relevance of locations to a certain distance, or working with different shapes, having interception between those shapes. So many things I think can be done with OpenSearch. It's interesting that maybe the search itself is a small part of the scenarios we can use it for, and everything else is like creativity is the limit.
Yeah, I think that OpenSearch is a that doesn't do it justice in terms of the usability of and how I've seen tools like OpenSearch being used. I think it is once you kind of grok the power that a search engine can provide, flexible search engine. I think it's pretty unlimited in terms of its use cases.
I agree.
Perfect. And another question was, what if you want to what if you want to specify a custom schema for our data?
Yeah, so in the example, I showed how we can use the dynamic mapping, and OpenSearch has ability to work without explicitly defined schema. But when we create an index, we can actually specify a schema which we want to have for the data. We also want to extend the schema, the index with extra properties, extra fields, and then add information about them. What we cannot do is update or change existing fields because the data will be invalidated. So that will require reindexing. However, I think it's still pretty good to explore a data set which we don't know well, to explore it and rely on the dynamic mapping, and then adjust it to what we need and to use a specific schema already, like which will give us a bit more probably certainty over fields we want to use and help avoid certain situations.
Perfect.
I had one question. Sorry, Torsten.
Yeah, go on.
What's your thoughts on using OpenSearch as the primary data storage? So not storing data in other systems and indexing it, but using OpenSearch as the primary data store?
I think each data store has their own goals and optimized for different scenarios. So OpenSearch is optimized for searching. So I think it depends on situations, and I wouldn't use it for places where maybe Postgres would be a bit more convenient way. So it's NoSQL data store, so it has advantages, but again, I think we are usually looking for like convenient tool for a given scenario.
Yep.
That's my opinion.
Yeah, cool.
Yeah, perfect. Thanks. So, as we do not have any further questions in chat, and as I can see, track 1 is wrapping up also, I thank you very much for being here, for giving this talk. And I will move this stream back and merge it together with track 1 as we started for the closing of our conference day. So thanks again for being here.
Thank you.
All right.
Überreden kann man ja gar nicht sagen, aber die davon überzeugen, dass das sinnvoll wäre.
Naja, du musst die Vorteile aufzeigen, was die Cloud alles mit sich bringen kann. Du musst die Vorteile aufzeigen, plus da gibt es ja auch noch diverse Möglichkeiten an Incentivierung von AWS im Rahmen von der finanziellen Unterstützung, die man durch das MAP-Programm zum Beispiel bekommen kann. Und es ist immer eine individuelle Situation. Man muss gucken, was bewegt dieses Unternehmen, wodurch wird es getrieben. Du hast ja meistens Abteilungen, die so ein Unternehmen ganz besonders bewegen. Meistens ist es natürlich der Sales. Du musst einfach gucken, wie kannst du solche Unternehmen, die halt wirklich dann der Haupt-Business-Treiber sind oder der Haupt-Revenue-Treiber, wie kannst du denen das Leben einfacher machen? Was für Vorteile sind für die drin durch so eine Migration? Und dann stößt du meistens auf offene Ohren.
Das klingt nach einer super Strategie.
Und die Vorteile sind in der Regel nicht technischer Natur. Also,
ganz genau.
Dass das Tooling besser ist, dass es ganz viele Open-Source-Sachen gibt und so weiter, hat an sich für viele Leute jetzt keinen direkten Businesswert. Das heißt, gerade wir Techies haben da manchmal unsere Schwierigkeiten, das den eher businessorientierten Führungskräften zu verkaufen. Deswegen bin ich auch nicht im Marketing oder im Vertrieb.
Ja, man muss sich halt wirklich so ein bisschen von der Technologie lösen und gucken, was ist der eigentliche Business Value, was du durch die Technologie erreichen kannst. Sei es ein schnelleres Feature Development, sei es Kosteneinsparung etc. etc. Wie es dann umgesetzt wird, das ist dann relativ egal. Das muss halt einfach nur passieren.
Und da darf es auch ruhig agil sein, damit die Entwickler glücklich sind.
Ja,
das genau, nur ein paar Buzzwords zu droppen.
Genau.
Naja, ich glaube, die anderen kommen jetzt auch schon langsam dazu. Ich habe gerade gesehen, Backstage ist schon kommuniziert worden, dass die Tracks gemerged sind.
Oh ja, DevSecOps wurde noch nicht gesagt.
Oh, oh.
Hier gerade Rinon aus der Schweiz hat gerade noch kurz reingeschrieben, wir müssen unbedingt DevSecOps droppen, sonst ist das keine vollwertige Konferenz.
Hiermit geschehen.
Ich würde sagen, ich droppe jetzt noch mal ganz kurz ein Video und dann kommen wir alle gemeinsam wieder auf die Stage.
So.
So. Ja, ich bin auch wieder hier.
Willkommen zurück.
Ja, ich schaue mal ganz kurz, dass ich hier ein bisschen Platz schaffe im Studio. Und genau, willkommen. Wenn jetzt jemand vielleicht noch Backstage kurz unseren anderen Moderatoren und Orgas Bescheid sagt, dass sie jetzt wieder zukommen können, ich habe wieder Platz geschaffen im Backstage-Bereich, dann können wir auch alle anderen noch mit auf den Screen nehmen. Ich sehe gerade, da kommen noch ein paar rein. So. Stefan ist noch nicht da. Ansonsten sind wir vollständig. Alle, die on Stream oder auch im Chat aktiv waren oder im Hintergrund wild Dinge geklöppelt haben und geschaut haben, dass es funktioniert. Ja, freut mich, dass es funktioniert hat. Ah, Stefan ist da. Perfekt. Dann hat meine Zählung gestimmt. Ich hoffe, ich habe keinen vergessen. Ich kam auch auf 9. Es freut mich, dass tatsächlich alle jetzt noch da sind. Ich denke, es war eine gute Konferenz. Vielleicht sagt jeder einfach, es kommt doch jemand. Ja, wild. Oder es erzählt mir nur hier Quatsch. Vielleicht mag einfach jeder reihum noch kurz 2, 3 Worte sagen zu, wie er den Tag so gefunden hat und was es dann noch so ganz Wichtiges gibt, was man noch unbedingt sagen muss. Linda, fang an oben im Eck.
Ich fange gerne mal an. Ich glaube, beziehungsweise bei mir im Track war zumindest kein Österreicher drinnen. Also was ich für mich auf jeden Fall mitnehme, ist, dass wir in Österreich auf jeden Fall AWS mehr promoten müssen und schauen müssen, dass auch die Community-Events mehr besucht werden, auch die gesamten gemeinsam. Und ich hoffe, dass wir uns bald wieder alle vor Ort sehen und wirklich in Person, weil viele von euch oder eigentlich niemanden habe ich noch so wirklich in echt gesehen, nachdem ja keine Wiener Österreicher heute da sind. Aber es hat mir sehr gut gefallen, es war wirklich cool und sehr interessant und ich rede immer viel zu viel.
Ja, da mache ich kurz weiter, also von meiner Seite auch. Ich denke, wir hatten einen super Tag, einen super Track. Nochmal vielen Dank an alle Speaker. Was für mich immer ein Zeichen ist, dass alles gut läuft, ist, dass eigentlich die Zeit wie im Fluge vergeht. Also wir hatten jetzt 5, 6 Vorträge und eigentlich gefühlt eben erst angefangen und jetzt ist es eigentlich schon vorbei. Ja.
Ja, dann würde ich sagen, mache ich einfach kurz weiter. Ich meine, das war mein letzter Live-Community Day in Hamburg vor 2 Jahren. Nächstes Jahr in Leipzig, oder?
Genau.
Ja, das wäre super gut. Also ich finde es super, dass ihr das auf die Beine gestellt habt, trotz allen Widrigkeiten. Wir, Chris und ich, haben versucht zu unterstützen, wie wir können, aber was einfach super ist an dem Community Day ist, dass es eben nicht von AWS getrieben ist, dass die Community vielleicht auch über Sachen sprechen könnte, über die wir jetzt nicht so direkt sprechen. Und insofern, glaube ich, war es wirklich sehr wertvoll für alle Beteiligten. Wir haben jetzt bald die Reinvent. Und ein paar von euch werden auch dort sein. Ein paar von euch werden wahrscheinlich nicht dort sein und wer weiß, vielleicht gibt es ja doch die eine oder andere Gelegenheit, in den örtlichen Meetups eine Public Viewing Session für die eine oder andere Keynote zu machen. Ich selbst bin in München, das heißt, ich bin in Reisereichweite zu eigentlich egal wo. Daher sagt mir einfach Bescheid. Wien zum Beispiel, Wien wäre toll. In Wien war ich schon lange nicht mehr. Wir sollten auf jeden Fall schauen, dass wir soweit es die Möglichkeiten gibt. Natürlich müssen wir alle nach wie vor sehr vorsichtig sein. Die Situation ist nicht vorbei. Aber einfach, ich würde euch alle gern mal wieder persönlich sehen. Und diejenigen unter euch, die ich noch nicht persönlich getroffen habe, würde ich auch gern mal persönlich sehen.
Unbedingt. Und ich muss ganz kurz einwerfen, also wir werden in Wien auf jeden Fall was organisieren. Und Dennis, ich rechne sowieso damit, dass du kommst, also schon die ganze Zeit. Ich habe mich für Montag im Kalender eingetragen, dass ich dass ich dir sage, dass du kommen musst.
Ja, dann kommen mir schon die Tränen von. Nein, dann komme ich natürlich nach Wien.
Mit Stickern.
Ja.
Es war nur wegen den Stickern.
Und wegen dem Bier.
Ja.
Gut. Machen wir weiter? Chris, direkt weiter? Machen wir so.
I was going to ask, the English language track. I dipped in and out. I really enjoyed Olena's presentation there at the end, but it made me so hungry. I haven't had my dinner yet. She was talking about OpenSearch, and all of her examples would involve food.
And beer and garlic.
And beer and garlic is amazing. We need more Ukrainian speakers.
I want to try beer and garlic soup so bad right now. I have no idea what it is, but I'm sure it sounds pretty good.
Okay, ja, Stefan, dein Feedback. Du warst
ich bin auch
sehr stark im Hintergrund
lustig jetzt nach dem ganzen Zuhören vom Essen. Und war mein erster Community Day in der Backstage und unheimlich spannend, unheimlich toll weil halt wirklich, man merkt diesen Community Spirit, alle raufen sich irgendwie zusammen, manches funktioniert, manches funktioniert nicht, aber das macht trotzdem Spaß und war sehr aufregend und ich freue mich schon auf das nächste Mal.
Wunderbar. Aaron.
Yeah, representing the English track, I think we had a really good mix of talks. I think we had some really deep technical talks, and then we had some kind of really kind of thought-provoking ones. The voice authentication one, I think I'm going to be, awake tonight thinking about that talk, because I think it was quite a topical thing, and I think quite thought-provoking. So I think there was a really good mix of technical talks, kind of going into detail and getting a deeper understanding of things, and a good mix of sort of higher level talks. So I think from the English track, I think that was really what I thought was we had a good mix of talks. So I think it's always good to kind of mix it up and not just kind of go so technical all the time. I think we had a really good balance, I think, and that's what I was really happy about.
Perfekt. Ja, Philipp, dein Kommentar.
Ja, ich bin eigentlich jedes Mal wieder erstaunt, wenn man so das begleitet, wie die ersten Planungen losgehen, bis mit dem CFP startet, bis dann hin zur eigenen Konferenz. Das ist manchmal schon chaotisch. Aber letztendlich kommt eigentlich immer ein gutes Programm raus. Wir haben sehr gute Vorträge gehabt, haben alle sehr gut gefallen, die ich angeschaut habe. Und ich hoffe auf jeden Fall, dass wir uns mal wieder vor Ort treffen, weil das ist genau der Teil, der uns heute noch gefehlt hat.
Genau. Und ich habe gesehen, du hast im Hintergrund schon den nächsten Deal ausgehandelt für den Track 1, Talk 1, der ja etwas verkürzt war auf technischen Gründen. Vielleicht magst du es gleich ankündigen.
Ja, genau. Für die CDK Happy Hour, die deutschsprachige CDK Happy Hour, die wir quasi jeden Monat eigentlich haben, Thorsten und ich, haben wir den ersten Talk einfach nochmal uns reserviert. Und wir starten am 3. November um 17 Uhr, dass wir uns das Ganze nochmal gemeinsam anschauen. Und genau, auf meetup.com kann man das auch noch.
CDK Happy Hour, genau. Genau, da wird Sebastian dann nochmal den ganzen Talk, hoffentlich ohne Sturm und Stromausfall und was auch immer, durchführen können. Rinon, deine Zusammenfassung. Ich hoffe auch on-site hat alles gut funktioniert.
Ja, also ich war ja eigentlich nur hier, um Bier einzukaufen, Chips, Hugo, Wein und Pizza zu bestellen. Das war ja nicht hier meine Hauptaufgabe. Nein, wir haben hier das sehr gut zusammengebracht. Ich hatte ja damals gestartet, das zu planen, und dann haben wir das zusammengeführt. Mit dem österreichischen und deutschen Event hat es sehr, sehr gut geklappt. Die Zusammenarbeit war sehr, sehr gut. Und das ist immer eine Herausforderung. Also es ist jetzt der zweite Hybrid-Event, den ich mache. Und dieses hybride Ding ist doch nach einem Ticken mehr dann als finde ich, als wenn man nur vor Ort macht oder nur online ist. Das ist noch so
Das
das
ist klar.
i-Tüpfelchen obendrauf. Hat aber sehr gut geklappt und ich hoffe auch, dass wir uns bald sehen wieder mehr. Also wir fangen jetzt in Zürich an, vermehrt alles wieder vor Ort zu machen, weil es das möglich ist mit gegebenen Sicherheitsmaßnahmen. Ich hoffe, dass ihr dann auch vielleicht mal hier vorbeischaut als Speaker oder einfach zum Bier essen, Bier trinken und Pizza essen, hoffentlich. Ich hoffe, mein Hochdeutsch geht.
Kriegen wir hin.
Einigermaßen.
Wir haben hier eine wilde Mischung.
Ja.
Ja, dann auch von mir, ich fand es auch ein super Event. Hat mich gefreut, dass doch wieder so viele Leute mitgewirkt haben, als Speaker, als Organisatoren, als Zuschauer natürlich. Vielen Dank an die ganzen Zuschauer, die uns begleitet haben und die uns noch in Zukunft hier begleiten werden, die wir jetzt schon begrüßen können, wenn sie dann in Zukunft diesen Stream anschauen werden, dieses Recording. Das ist ja der Vorteil von Online-Konferenzen. Sie sind ja für die Ewigkeit gemacht, mit allen Vor- und Nachteilen. Und gebt uns Feedback, schreibt uns an auf Twitter, schreibt uns direkt an, unsere ganzen Handles stehen drunter, schreibt an den AWS Community DE Handle, meldet euch bei uns, schreibt in die Kommentare von den YouTube-Videos. Wir freuen uns über alles Feedback, das wir bekommen können, natürlich über positives Feedback noch viel mehr. Reinvent wurde schon angekündigt, ist bald. Ich hoffe, dass bis dahin nicht so viel schief geht, dass es doch tatsächlich sowohl stattfindet, als auch wir einreisen dürfen. Und damit auch gern, Dennis hat schon angekündigt, er wird rumreisen, weil er nicht hingeht. Ich werde hoffentlich dort sein, aber mein Plan ist, mich von dort einzuwählen in einen Stream und eventuell direkt hier nach Deutschland, Österreich, Schweiz zu streamen und mitzuteilen, wie die Stimmung vor Ort ist und was es denn Tolles Neues gibt. Also auch hier gern, wenn ihr Events habt, schreibt mich an, wir können versuchen, da irgendwelche hybriden, weltumspannenden Dinge zu tun. Mittlerweile die Technik macht es ja mit. Ich meine, wir haben hier Streams auf YouTube gemerged. Ich meine, wenn das nicht alles ist und wir haben Dinge remote gestreamt von Platten, die woanders stehen, das ist magisch.
Also die Gelegenheit wirst du auf jeden Fall haben. Ich nehme dich beim Wort. Ich mache nämlich wieder Daily Recaps während der Reinvent, werde ich vom Münchner Studio aus machen und dann werde ich dich nachts aus dem Bett klingeln, damit du uns Rede und Antwort stehst. Das kriegen wir hin.
Interessanterweise, ich weiß nicht, was sie in Vegas tun, man ist dort auch nicht müde.
Nein.
Man steht um 6 Uhr auf und man geht um 2 Uhr ins Bett und es ist überhaupt kein Problem eine Woche lang. Es ist irgendwas, ich glaube, es liegt einfach am Sauerstoff, den die überall einpumpen. Aber man ist einfach nicht müde.
Das ist wie bei der Matura-Reise.
Vielleicht ist es auch wegen Wasser oder weil immer Licht ist überall und keine Fenster.
Keine Ahnung, woran es genau liegt, aber es funktioniert. Es ist auf jeden Fall sehr hilfreich für so eine Konferenz. Gut, das war auf jeden Fall unser Community Day Deutschland, Österreich, Schweiz 2021. Nächstes Jahr tatsächlich hoffentlich vor Ort. Ich gehe stark davon aus. Leipzig war eigentlich für letztes Jahr schon gesetzt, dann haben wir es verschoben auf dieses Jahr. Ich hoffe, dass wir es dann nächstes Jahr hinkriegen in Leipzig. Und ja, genau, die Partyseifen blasen. Und dann bleibt mir nur noch zu sagen, vielen Dank auch nochmal an unsere Sponsoren und macht's gut, bleibt gesund, wie man so schön sagt, und bis zur nächsten Veranstaltung.
Ciao, danke.
Bis später. Ciao.
Ciao.
Tschüss zusammen.
Tschüss.